fix the eye bolts on the mounting flange as seen in the video. Attach the slings on the swivel eye and inside the shackles.
Everyone, please be seated. Yeah.
Do not attach the slings directly onto the silicone sheds as it might severely damage the sheds. Attach the slings to the crane hook and lock the safety latch. Now start lifting the bushing. Make sure to balance.
Good afternoon, everyone. Welcome back to our workshop of Trafo Care 7th edition. We are starting the session now. Everyone, please be seated on your places.
चेंज है हम इसमें मिस्टर मनीष पांड्या थोड़ा एक फिलर डाल देते टिल द टाइम पीपल गुड आफ्टरनून फ्रेंड्स एक ही गुड आफ्टरनून सुनाई दिया सर मुझे ओ केयरफुल केयरफुल प्लीज प्लीज केयरफुल सर थैंक यू सो मच वंस अगेन गुड आफ्टरनून एवरीवन नहीं खाना या तो कम हो गया या तो फिर नींद आ गई दोनों में से एक है यस गुड आफ्टरनून एवरीवन perfect so we have a small announcement today and I really thank especially utilities like team from MPTCL, PGCL to make session more and more interactive. Especially the questions asked to the author and the subject experts were really deliberated very well and knowledge has been spread. I believe that at least I gained some knowledge. So may I request Mr. Manish Pandya please. Mr. Manish Pandya from सर थोड़ा आगे आइए आपको सर पनिशमेंट मिलने वाला है आपने बहुत क्वेश्चन पूछे इसलिए सर वो कुछ फांसी का फंदा लेके लोग खड़े वहाँ पे आपने बहुत परेशान किया है हमारे ऑथर को सो मिस्टर प्रणय जोशी फ्रॉम MPPTCL मिस्टर प्रणय यस सर आपने भी कुछ बैठे बैठे कॉर्नर से कम परेशान नहीं किया है सर एंड मिस्टर दिनेश कवले दिनेश कहाँ थे इधर कभी तो मैं टेबल के पास देखा था मिस्टर दिनेश कवले मिस्टर दिनेश आइए सर आइए आप आगे आइए मिस्टर दिनेश कवले सर आप आइए जल्दी वो फांसी का फंदा आपके लिए इंतजार कर रहा है अच्छा एनीवन हु डजंट अंडरस्टैंड इंग्लिश कोई यहाँ पे है जो इंग्लिश समझता नहीं आई मीन इंग्लिश इज फॉरेन लैंग्वेज इवन टू ऑल ऑफ अस मे बी इंक्लूडिंग मिस्टर राइडर सो ही मे एग्री सो एनीवन हु डजंट अंडरस्टैंड इंग्लिश कोई इंग्लिश यहाँ समझता नहीं मुझे भी नहीं आती तो वी विल ट्राई टू मेक सम इन बिटवीन कन्वर्सेशन व्यक्ति है खड़े जनता मिस्टर स्पेशली राव साहब का सेशन मिस्टर प्रमोद राव अच्छा किधर है अच्छा नहीं क्योंकि फांसी का फंदा उनके पास में एनीवे सो इन्होंने सच में सेशन काफ़ी इंटरेक्टिव बना लिया एंड मिस्टर प्रमोद राव एंड हिज टीम सेड आई रियली थैंक देम फ्रॉम बॉटम ऑफ आवर हार्ट एंड मे आई रिक्वेस्ट संजय जी प्लीज एंड ओके मतलब बाय वन गेट वन फ्री सर इसलिए आपको मतलब पूछने की जरूरत नहीं अरे सर आपको भी आना है इतनी चमक कहाँ पे आएगी बालों पे So they have a small token of appreciation for making this session more and more interactive. So please, yes. And big applause of the claps, please. थैंक यू सर, उसके अंदर का फांसी का फंदा आपके लिए, आप खुद जाके खुद लगवा लीजिए. थैंक यू, थैंक यू. I hand over to Palak to take the program next level. Thank you so much, Palak.
Thank you, sir. We will be starting our next session now. Give me a moment. I would like Mr. Patnaik, sir, to please come on the stage.
चाहिए ना, आप स्टेज में जाके स्टेज
Good afternoon, everyone. Once again, welcome to the workshop of Trafo Care, the 7th edition. I hope everyone is back to their places, had good lunch, and everything is fine with everyone. I hope people are happy by getting some good gifts from our special speakers. The session was very interactive, so there were good gifts for everyone. And the lucky draw was also, I think, very interesting. So now we will be starting up with our next session. Our next session will be chaired by Mr. Patnaik. I would like to brief you all a little about Mr. Patnaik. Mr. Patnaik is a Senior General Manager from OPTCL looking after the EHT O&M Circle, Bhubaneswar, Odisha. He is having 33 years of experience in designing, testing and commissioning of protection, control and operation schemes, project implementations, coordination and cooperation and maintenance of electrical equipments at various LT and HT, EHT level grid substations. He has his expertise in the GIS, SAS protection control and special maintenance of transformers and EHV equipments on conditional monitoring, assessment and fault diagnosis. He has published more than 100 number of technical papers in different national, international proceeding journals. He is a regular author at the journal publication by reputed organizations like CBIP, EMA, Electrical Mirror, Electrical India and many other. He is also an author of many electrical books on electrical technologies and awards in many of the national and international forums. Mr. Patnaik has recognized his Best Engineer Award and Special Appreciation Award in OPTCL in the year 2013 and 2018 and also in the year 2020. Best Paper Award during the International Conference Meeting India in 2018 and 2020 and the Appreciation Award from CBIP, EMA and many other international forums. He is also the admin of the nationwide technical group named SPARK, having 600 engineers all across the nation with 19 main groups and 8 substations. Now I request Mr. Patnaik to kindly chair the session further. Thank you, Mr. Patnaik.
Sure. Good afternoon, everyone. Yeah, actually, I just heard one good afternoon. The person who was insisting for you to speak of a good afternoon. Once again, good afternoon, everyone. Yeah, it's fine. So, before to start this session, I will be asking one query to my friend Shinde Saab. एक query है आपको. So I just found that he was honoring. I mean, he was asking for honoring the people to ask the queries and all. In this session also, you can ask those queries, whatever you feel, and it will be really interactive session. We must have to make it of a very interactive. And another most important also, discussing with Negi sir also before to this session end and before to the lunch. Tomorrow we are going to have in the last session one of the session called the question answer session. That is of a FAQ on operation and maintenance of a transformer. Why I am just emphasizing this before to start this session, on that session, the all experts be coming on the dais and you are free to ask the number of queries and all. Whatever the queries you mean to say within of these 2 days. And another most important point also, there is one book is there in your kit bag. That book will be released tomorrow, but that book is already been distributed to you in advance. You please go through that book. Tomorrow, you may ask the queries from that book, or if you are already well into the answer of that particular one, what been answered over there, then need not to ask the queries, but you can ask those queries and all. So, my sincere request, that book name is called Practical Query Based Compendium on Operation Maintenance of a Transformer. That has been compiled by me, and it will be released tomorrow, but already been distributed to you. Please go through that book. It is of containing 60 pages. There number of queries is been given, and it has been answered also all the eminent experts across the country. I am only the felicitator or facilitator for making the things to get it compiled and all. Anyway, so thank you. Now, I will ask Dr. C.S. Narasimhan, please come up the dais. Engineer Amay Kulkarni, please come up the dais. Engineer Y.V. Joshi, please. And Engineer Pattan Satti, please come up the dais. Engineer Chawda also, please come up the dais. It's my great pleasure of being here and to chair the session, because all my gurus are there in the left and right, and I bit nervous also to just conduct this session, but timing is most important. We must have to give real justice to each and every session and also to each and every speakers upon here. Before to start, there is one small change in the orientation. First of all, Dr. Chawda is busy otherwise and having some flight connectivity and all. So he will be presenting at first. Need not to give the introduction of Dr. Chawda, because already you have been introduced with him in the session number 1. So coming to next, Dr. C.S. Narasimhan. So Narasimhan, actually no need to give any kind of introduction to doctor, because he has already published a number of IEEE conferences recently and also published a book. That is of most important. Anyone to just publish a book means everything of his own thought process get reflected in the book. So that is the most important book, Transformer Oil Application Aspects, published by Merit Media, Croatia. He has been a member of several IEC and SIGRE committee. So I'm not going to take any much time, because we will be directly landing to the discussion part and presentation part and all. So he is currently associated with Sabita Oil Technology and well into this, one of the renowned expert of Indian sector. Next comes Engineer Amay Kulkarni. He did his BE in Electrical Engineering from Mumbai University, fine, because here itself the Mumbai, and also he is the BE graduate of that. Having up for 17 plus years of extensive experience majorly in transformer, generator and all. Particularly he is working on the K-class ester oil across the industry. So that is the expertise of Mr. Kulkarni. And we will be coming to Engineer Y.V. Joshi. I mean, need not to give any kind of introduction to Joshi Sahab, because he is already is there. And of course, it will be injustice if I will not be speaking upon him. So he is the former head engineering GATCO, then past president EREDA, now also member of a SIGRE NSC in all committee, maximum committee, A2, A3, B3, B2, B3, BIS committee also is there. And he is the technical director to I Power Lab and also the knowledge cluster, the one where we are just having, who is organizing this one. He is also the technical director. So Engineer Joshi. Next comes the Pattan Satti. So I can say Engineer B.B. Pattan Satti, if I will be giving you one sort of introduction. When I was there And I've been to Delhi. They were conducting some conferences on the behalf of a CVIP. I heard the kind of interaction with engineer Patan Sethi. It was of really fantastic. The vocabulary, the way of speaking, that is of most important. That is his introduction. Whenever he will be presenting, you can feel the way he speaks, the eloquence, and the way of grabbing the people, and the way of getting into your subject matter and all. But he is very well into this subject, and having a patent also, like 4 number of patents in his name. You just feel the reputed experts are sitting here with me. So one of the patent comes with a high temperature composite insulator of transformer, online gas extraction for transformer diagnostic monitoring applications, fluorochlorinated biphenyl neutralization system, nano observant for transformer oil reconditioning. So you have got 2 experts as per the transformer oil is concerned. Narsvinan sir will be talking about so, and also Patan Sethi sir also may be talking about transformer oil, I think so. So this is the introduction phase of all our great speakers over here, the eminent speakers over here. And at the same time also, those are on the opposite way. Already Jitubhai Mamtara Sahab is there also. He is another renowned face here. And Negi sir is also there. Then number of eminent speakers, eminent experts are all there. Each and every one is of attending here, like Trafo Care conference means you are all experts. So probably you will be also on that way to ask those queries, because whenever you ask the queries, गले का फंदा आपके गले में भी लग सकता है. So you just ask the queries. Hopes also will start. So we will be starting with Chawda Sahab. Chawda Sahab, please on the line. How many? What is the? What the time? 90 minutes. 90. Okay. So it is 15:05. Okay.
Okay, good afternoon. Please play my presentation. Okay, I will move fast because we are running late. And if any question, you can ask me anytime, no issue. Okay. Today my subject is transformer care with digital asset management and condition monitoring. So my brief introduction given no issue. JETCO overview, asset management digitalization, transformer condition monitoring, JETCO field case study, and a major challenge till we are facing. There is an overview of power sector. I am not giving much more time. But after unbundling in 2005, from GEB to all 6 companies, there is a phenomenal growth. Okay, so this is a comparison. In 2004 and 2022, the network is developed in Gujarat. Our system availability is high, substation availability is, line availability is high. And transfer capacity addition up to 1,62,000 is there. Now, our plan is up to next 10 years, we are at double our transformer capacity in MVA. Okay. And it is anticipated load of Gujarat. Okay. In 10 years, it is our plan to invest 95,000 crore of rupees in Gujarat power sector. This is our planning. And we see from 2004 to 2022, network is this, and we are going to convert in 2032 like this. So there is a huge planning and investment in Gujarat in power sector. So now the concern for power sector utility to create new asset and integrate RE power which is non-reliable and to provide reliable quality power, as well as to maintain old asset in service and face competition due to TBCB. Nowadays, we are not a monopoly business, but we are also in a competition. Okay, so there is a main 2 objective of power sector utility: to prevent equipment failure in grid and to increase the residual life of equipment. This is the main 2 objective. So we are avoid to such occurrence in my grid, and we increase the service life of transformer. Oldest man in India is Swami Shivananda, 110 years till today working and do exercise in the morning. So this is my oldest transfer in service at the 60 years. Okay, it 132 kV go 3 substation. We compare with men, its age is 150 years of transfer. Now to achieve this objective, main focus area of the utility is asset management, condition monitoring and corrective action. These three all action required. Now we took first asset management. If there is a nuclear family, then there is no issue to manage. But if there is a nuclear bomb family, then it is quite difficult to manage the asset. This is the Jiano China, total 167 family member. So it is quite difficult when the family is big. So for that, we have to move towards digital asset management. Okay, and JETCO has started TAMS, Transmission Asset Management System. We have developed by in-house and we have presented in SIGGRAPH Paris and it is recognized as a best paper. It is totally developed by our employee and we do the necessary change as required, as and when required. So provides total information of your equipment, of your asset. This is the TAMS dashboard. Substation numbers we can go easily. Power transfer, total 6,000, more than 6,000 power transfer is available, voltage class wise. And we also kept the record of transfer oil where is available. This is the example of TAMS. Okay. Now, the second objective of the condition monitoring. The transformer care means health monitoring of power transformer. Check the parameter of power transformer at regular interval or continuously online measurement which can indicate the health of transformer and give an early alarm. And then analysis of the result. And third one is the corrective action. If all three are covered, then and then we can achieve our objective. So, as we after 40 years do regular health checkup, same way we do the transformer health checkup. I have compared some analogy. Strength versus iron PI, diabetes versus 10 delta. X-ray is the similar to SFRA. Blood is the same DGA we will do for main. BP versus degree of polymerization, paper insulation strength. Bone marrow test, tensile strength of paper. CT scan, partial discharge of power transformer. And sonography, we will do all the thermography of our power transformer. So, total 13 numbers of health checkup test we do offline and 5 numbers of health checkup do online in our grid to reduce the failure of the power transformer. So this is the one slide which cover all this my objective and how we can do. This is the single slide I have tried to describe. Not only that, we have incorporated condition monitoring criteria in TAMS. So all logic of condition monitoring test are included in TAMS. So when you enter the result in TAMS, TAMS itself give you the guideline about please retest after 3 months, please replace the CT, please recheck the transformer, please switch off the transformer. When there is a gas is high, if you enter the result in TAMS, it give clearly indicate please switch off the transformer. So this all oil diesel test logic we have incorporated in my TAMS. So this is the actual window of TAMS. Oil routine test also we have added in TAMS. And transformer bushing 10 delta also we have added TAMS. When I click on a transformer in single window, all the oil DGA, routine, bushing 10 delta, winding 10 delta, all the test of the transformer came in the single picture and it indicate health index of the transformer. And on basis of the health index of the transformer, we take decision regarding overhauling of the transformer, regarding inspection of the transformer or regarding the oil replacement of the transformer. So, I am explaining very fast just the DGA. So, in JETCO there is a regular practice to do DGA each and every year. So, what benefit we achieve from the DGA? This is the case study. 50 MA transformer, DGA indicate high key gases, at the routine test. Okay. So, you see in this case, all the key guesses are increasing. So, shutdown taken of the transformer and all routine tests carried out. All other routine tests found normal. So, it is decided to open the transformer. So, after concern with OEM, we open the transformer at site and total oil drain. And in inspection, it is observed that in B phase, the aluminum foil is touching with core. Okay, and so this aluminum foil is removed, re-insulation provided, and transformer put back into service. So there is a saving of 1.55 crores approximately. This is the single case study of DGA. The second case study of capacitance and 10 delta. Each and every year we regularly measure the capacitance and 10 delta test. So this is the 130 by 60 kV 40 MA transformer. So you see at the routine test annually we observed in this only CH winding 10 delta is increased. Other two winding 10 delta is normal. Okay. So in HV winding there is a HV bushing and OLTC. So we check the 10 delta of all the bushing, yes it's okay, and check the BDV of OLTC oil, it's found okay. So it is decided to inspect the transformer. So after total oil drain, transformer inspection carried out, and you see in barrier board we found some tree. Okay, so we confirm that by removing this all connection of barrier board, 10 delta taken at 1 kV and result found normal. So it is confirmed that there is a issue in barrier board. So barrier board replaced and transformer put into service. Here I want to just give some highlight that without oil, please do not test the transformer at higher voltage. Okay, otherwise there is a chance of fire. Please do not test winding resistance at higher ampere also. So this transformer result found normal and we put back into service, and other after filtering we test all the 10 kV. Okay, so 1.40 crore saved in transformer. So this is the another use of 10 delta. If we take tip up test, okay, then if the graph is found flat, then it is very good. Slope is uniform, then good. If there is a difference in slope, then there is a chance of PD. And there is a negative slope, please remove the bushing immediately or transformer. Clear? Okay. Now, the one of the case study of SFRA I want to explain, not going in detail, but directly go to this. In one of the our substation, transformer catch the fire. Okay. So after so many try and use, we extinguish the dire. This is the condition of the transformer after fire extinguish. See the condition. Okay. So in this condition, I have tested this transformer for SFRA without bushing. Okay. And compare with my base signature. And in base signature, I found that there is no issue in winding. Winding is intact. Okay. So we decide to replace all the damaged part and transfer put back into service. This is within 15 days, done by departmentally. So, one of the important case study of partial discharge, my 400 kV ICT trip in Bucos only, okay. So, study of DR is there. There is no electrical fault noticed in disturbance recorder. Transfer tripped only in Bucos. So, DGA test carried out and acetylene found in this transformer. So there is something wrong inside the transformer. But each and every test result found normal. So we winding resistance also found normal. So we worried and we checked the CFT, core frame earth, may be wrong, but core frame earth also found normal. So after every result found normal, we have decided to inspect the ICT. So ICT inspection carried out, but nothing found in ICT. So it is again worry for us what to do. So we decide after filtration to charge the ICT without finding fault. Okay, it is quite danger, but we charge the ICT, and at that time we kept PD kit of acoustic and my PD kit also there. So after charging the ICT, we do the PD survey kit. There is a PD found in B phase, and by acoustic, there is a PD generated area. We found that. So after deciding location, again we inspect the ICT, and we found that here in bushing there is a place mark. So this is attained and transfer put back into service again. So 3.55 crore we have saved. So there is a good teamwork. By doing this all condition monitoring activity, our transformer failure is very less compared to national failure rate. So not only transformer, we have reduced all this other equipment failure rate also reduced. So this is the old power transformer when I joined my duty in 1989, and this is the new transformer. Okay, this is the complete bushingless ester oil transformer. There is a 100% insulated transformer. There is no chance of fault. Yes. Yet some new technology we have adopted in transformer, natural synthetic ester oil, huge number of transformer in our service, more than 300 transformer of ester oil. 220 kV EHV transformer we have also charged with ester oil and in service. Now we have adopted RIF bushing, air cell, read type glucose relay, PRV, NIPS, online monitoring DGA PD, etc. adopted by JETCO. Okay. Now, some new technology required in transformer. Core material should be upgraded, better flux density, efficient cooling bank we required. Now we require slim transformer. Vertically it should be high, but I have to accommodate in industrial area or in city area. Dry type transformer we required for indoor GIS. In existing bay with higher capacity of transformer we required. Hotspot monitoring. We also try to monitor the transformer by online SFRA, online winding 10 delta, low dB level, particularly in reactor, low weight, uniform design. This is the dream of our Honorable MD Sri Negi sir. Uniform design of all the transformer if possible, then it is quite easy for all utility. Easy replacement will be there. So this is our requirement. So work hard, stay positive, never give up. Any question? Thank you.
Thank you, Dr. Chawda. Actually, you are well into the time. And we can take up one question right now, and you can submit up also the other queries at the end of the session. One question we can take right now. Yeah, please.
Thank you, sir. Myself, Harinder Kumar Singh, coming from BSP TCL Patna. As I am working as an electrical superintendent engineer, transmission circle, Dairy on Son. सर मेरा एक क्वेश्चन है कि सर आप लोग सर इतना स्टडी किए, बहुत अच्छा सर लगा सर, ठीक है। हम लोग सर हम लोग ये फिल्ट्रेशन कराना चाह रहे हैं सर। ट्रांसफार्मर मेरे पास है, ओल्ड ट्रांसफार्मर भी हैं, न्यू भी हैं। तो ये फिल्ट्रेशन का ड्यूरेशन सर आप थोड़ा बताएंगे सर, कितने समय में हमको फिल्ट्रेशन होना चाहिए या नहीं होना चाहिए? फिल्ट्रेशन जो हम लोग ऑयल फिल्ट्रेशन करते हैं ना, तो उसका ड्यूरेशन क्या होना चाहिए?
योर क्वेश्चन इज ट्रांसफार्मर का फिल्ट्रेशन कब करना चाहिए?
जी सर।
यस, वी मॉनिटर द 10 delta value, okay, and if my 10 delta is higher, okay, then we do the filtration. Yes, listen carefully. If my 10 delta is between 1 to 3%, then we do the filtration. If 10 delta is beyond 3%, then we do the overhauling. Okay, and we also monitor the time delta higher, but in which part? HV winding, LV winding, or between HV and LV? It depends on that. Okay, but before take a decision regarding oil filtration and overhauling, frequency domain spectroscopy test is nowadays quite useful to take a decision. Okay.
Thank you, sir.
Okay, actually, I will be adding one point over here. Whenever to take oil conditions and all these things for filtration purposes and all, one is the oil tan delta is to be taken into account. That is one. Second point also, the oil parameters is to be seen. Third and most important condition, how your transformer is running. Suppose transformer is having a leaky transformer, वो leakage हो रहा है, तो in that case, whatever the way you go for, it will not solve the purpose. That's why you have to go for studying all these parameters finally to decide how it will be seen. As it has been considered in the way, so I can take one of the most important takeaway from Dr. Chowda's presentation, which has been clearly mentioned. He repeated twice also in that aspect, that if oil is not there in the transformer, don't go for any kind of high voltage testing. That is the most important part. So, as oil is the most important parameter, our next session will be continued in that fashion. So, I will be requesting Dr. Narasimhanan, please, of the dais, and to complete it by 25 minutes. Is it okay?
हेलो
नहीं, हम लोग एक्चुअली आपका जो क्वेरी है ना लिख के रखी है, यू जस्ट पुट इट ओवर हियर, विल इन सीक्वेंस विल गो फॉर इन द क्वेश्चन आंसर सेशन. प्लीज जस्ट नोट इट. या बट 5 minutes कट्टल, 5 minutes only, 25 minutes please.
Okay, fine. Good afternoon, everyone. It gives me great pleasure to present before you and share a little bit of knowledge on mineral oils and ester oils. There are several dimensions to an ester oil, whether it is synthetic ester or natural ester. There are several dimensions. But then I have chosen a particular aspect which is extremely critical, that is moisture related and temperature related. These are the two issues which normally bother a transformer oil, transformer oil operator. And in that context, I wanted to see how, I wanted to present before you a comparative study between mineral oils and ester oils. Okay, I think before I start, I thought I will just show you a curve. It's a schematic curve, the knowledge curve versus our understanding curve. So knowledge is exploding. There is an explosion of knowledge in whichever field you take. And transformer oil is no exception. There is a huge gap between our understanding of what is already known collectively and what we understand. And of course, I have to add, coming after soon, immediately after lunch, the understanding, of course, after lunch will probably be even lower than the curve that I have shown here. So nevertheless, let me see to what extent I can do justice to the topic in the next half an hour or so. The topics that I'm going to cover are the following. The moisture sources in transformer. The most important topic that I'm going to look at is the moisture dynamic, the so-called moisture dynamics in ester oils in comparison with mineral oils. And more importantly, how the differences in the moisture dynamics, how they play out on the effects on the transformer. Then, of course, I will also consider the influence of moisture and temperature on insulation aging. Again, a comparison of mineral oil and ester oil will be given. And a little bit of explanation based on the unique chemistry of ester oils and its positive impact on loadability or life extension. Okay, now towards the end, I will try to cover mitigation techniques for oil and mitigation techniques for paper. Let me see how much I can cover. Why is it important? Why is it important to study moisture in an oil? It is because if you look at it, water management poses a continuous challenge to utilities. Water is the first and perhaps the worst enemy of a transformer. And at the same time, while it is the worst enemy, there is very little you can do about it. You cannot avoid, it is not avoidable. It is undesirable, but at the same time, it is unavoidable. The paper as well as oil is going to have some moisture, and in fact, it is desirable to have 0.5% moisture on paper to maintain its integrity. Okay, important consequences. Let us look at the important consequences of moisture in an oil. In fact, the bottom line is the bottom line. What you see in the red, that is the bottom line. The moisture in oil and paper, that will decide the loadability and safe operation of a transformer. If it is 2%, you take certain decisions. If it is 4% of moisture on paper, then one has to be very careful about the loadability of the oil. What all can happen if there is moisture in oil as well as on paper? You can have PD effects, partial discharge effects. You can have bubble formation. You can also have sudden oversaturation of moisture in oil, and so on and so forth. So this is just a representation of what all can happen when the moisture saturation increases in the oil. The PDV gradually falls and as the moisture saturation increases. Now this is a slide on moisture dynamics. This is what everybody talks about. What is dynamics? Dynamics is basically the movement or migration of moisture from paper to oil and oil to paper. And mind you, this happens continuously when the transformer is in operation. And what is equilibrium? Equilibrium is when there is no change in temperature taking place. Then we say the transformer oil is in equilibrium. There is no change in temperature. What is the best way to understand this? The best analogy is that so I was thinking of various analogies to understand this dynamics. One of the analogies which I am going to present to you, we can find out whether that is applicable. It's an easy way of understanding the moisture dynamics. We all have played musical chairs. In a musical chair, you arrange the chairs in a circular fashion, and we all keep running or walking around the chairs, and the music is on. As long as the music is on, everybody is happy. The music here indicates the temperature. That is, then there is a perfect equilibrium. The music is on. People are walking around merrily. And they in fact keep clapping to the beat of the music, and everybody is happy. The moment the music stops, that is what we call a non-equilibrium state in a transformer. That is, either the temperature is going up or the temperature is going down. So as long as the temperature is constant, that is, the music is on. And when the temperature goes up, either because of load increase or because of ambient conditions falling down to 20 degrees or 10 degrees, like in the Western countries, then you are going to disturb this equilibrium. So that is when all hell breaks loose. Like in the musical chair, people are trying to occupy the chair, whichever is vacant, and then one of them loses out, and so on and so forth. So that is what happens in a transformer essentially. The moisture dynamics this is what I have shown it here. When the temperature goes up, the moisture goes from paper to oil, and when the temperature goes down, the reverse migration takes place. So this is constantly taking place, and this is the non-equilibrium state. And in fact, most of the failures in transformers take place when there is a non-equilibrium state. In the perfect equilibrium state, when the temperature is constant, there is no failure reported generally, because everything is in equilibrium, then nothing happens. It's only when the temperature fluctuations take place either up or down in a drastic fashion, you have failures taking place. Okay, now here is a case study. I have given a couple of 2-3 case studies. 375 MVA, 150 20 kV GSU transformer, 35 years old, perhaps wet. It's switched on after several weeks of idling at -15. That is, it is idling at -15, and suddenly it is switched on. A few hours after increasing the voltage gradually, it exploded. The most probable reason, of course, is the fault is the fault identified is that sudden exchange of water in the boundary surface between solid insulation and oil. So when there is a sudden exchange, you have moisture coming in from paper to the oil. This will result in the bubble formation, especially if the paper is wet, and that will give rise to when the free water in the high voltage stress area is going to cause the failure. That's one case study. The second case study is just the reverse. A wet instrument transformer exploded in the early mornings, hours after the previous hot day. See, in the case study 1, the temperature had gone up because of loading the transformer suddenly. But in the case study 2, just the reverse has taken place. The previous day was a hot day, and when the wet transformer exploded in the early morning hours, following in the early morning hours, the cooling down of the wet oil overnight, it might have resulted in oversaturation with moisture and initiated. That means you have not given enough time for the moisture to go from oil to paper. So that is the non-equilibrium state. That means the music has stopped. So the temperatures have gone up, but you have not given enough time for the transfer to migration to take place, and that led to oversaturation. That means the moisture has remained in the oil. It has not gone back to the paper, so it has got saturated. It's saturated with moisture. The third case, this is a case of, again, of oversaturation. A 20 by 27 MVA, 66 kV, 38-year-old. Again, we are talking about old transformers which are where the insulation is wet. And under those conditions, one has to make sure that the temperature fluctuations do not take place. Of course, certain temperature fluctuations are not in our hands, but overloading can certainly be taken care. Now here is laboratory result of experimental data for an insulation sample of 2.5% moisture. Insulation containing 2.5% moisture. And you will find that as you increase the temperature or decrease the temperature, both ways, you will see PD activity building up. You can see very clear indication of the PD activity taking place. This is a laboratory study. The same thing is depicted here. The rate of rise of temperature or rate of fall in temperature, both give rise to changes in the BDV values. That is, the faster the change in the change of temperature, change of rise. That is, we are talking about the rate of change of temperature. That has an adverse effect. Rate of change of temperature, again, we are talking about the non-equilibrium state. So it's all about the non-equilibrium state. When a moisture is affecting a transformer, it is all about non-equilibrium state, driven by temperature changes. That is the most important thing to remember. Okay, now this is bubble formation. Is again a laboratory result. The bubble formation. What happens to bubble formation as a function of water content in paper, and the state of paper. The state of paper also has an effect on the bubble formation. Now this is, of course, we will talk about this a little later. This is about the paper degradation. Okay, now types of water present in the transformer. You have got dissolved water. There is absolutely no problem with the dissolved water. It is not even visible. But emulsified water, this will look a little cloudy, and a cloudy oil has the potential to affect the transformer. Now, free water, of course, will have disastrous consequences. Now, what are the sources of water? Okay, here I have sources of leakage in a transformer I have shown here in this slide. This is interesting data collected by the Russian engineer, scientist from the field transformers, various sources of leakage and its effect on the condition of the transformer, or the amount of moisture that can deposit in a transformer as a result of various conditions is given. And the bottom line is again here, exposure to high humidity during repair has the highest rate of water absorption. So this is based on the data collected from the field. Well, this is another source of water. When the paper is degrading, it produces water, and that is what is shown here. When it comes to preservation system, you are all familiar with the free breathing through silica gel, breathing through conservator, silica gel, and of course, hermetic sealing. These are the various insulation systems in a transformer. I will talk a little bit about moisture management in transformers. So, basically, we have to understand the moisture equilibrium, the moisture migration effects, and avoid the pitfalls in applying the standard. There are standards available, but then standards are not going to help because you are talking about a dynamic process which is constantly changing. The moisture is constantly changing its position. So while the standards like IEC 60422 they give guidelines, but then sometimes one can get into problems if you don't understand the moisture dynamics. Here I think I just wanted to show you the various types of insulations. Thin warm insulation I have shown in the middle. That is what contributes to the moisture dynamics. We are talking about the paper winding around the copper. That is what contributes to, that paper contributes to moisture migration. It is most dynamic with respect to that particular water on the paper. Here the moisture diffusion time constants are given for different papers. I think the most important thing is determination of moisture percentage in paper. This is a huge topic by itself, and I will just skim through the details. Yeah, this is the final outcome. This is the so-called Oman diagrams. Oman is a Keralite scientist who worked for ABB in the US, and he has done a lot of fundamental work on the oils and the paper and so on. So here is an interesting curve which all of us must be knowing. The relationship is between moisture in oil and moisture in paper. So it is very, this is a very useful way in which we can find out the percentage of moisture on paper. Now, important interpretation guidelines. This is important. I was talking to you about IEC 4022 guidelines. Okay, it is important to apply the temperature correction. Temperature correction, if you don't apply, very often you can end up in very wrong or faulty conclusions.
Dr.
For
Nas-
instance, if you have sampled that oil at let's say 70 degrees.
Doctor sir, actually another 5 minutes.
Huh?
Another 5 minutes, please.
Or 5 minutes, okay. Okay, so here is an example of how the temperature correction can lead to, see 20 ppm is what IEC standard says for poor condition of an oil at 400 kV. But then, depending on the temperature, this is a case study where early May it showed 14 ppm, early June 19 ppm. So this is an anomaly, this is a false alarm because the person has not applied the temperature correction. Now the moisture play, this is an important aspect of, I think I must be having 10 minutes. Yeah. The moisture play with ester oils and its comparison with mineral oil. This is the most important topic of my presentation because we have so far seen moisture. Here, how does it, see this is the most basic chemistry that is operating with the ester oils. We all know that, whether it is natural ester or synthetic ester. They have got excellent affinity for, thank you. They have excellent affinity for moisture, and that changes the whole picture. When you move from mineral oil to ester oil, this is the basic property of esters, which okay. Now let us see this particular slide here. This is an equilibrium diagram. On the y-axis, you have got the moisture percentage on press board, and on the x-axis, you have got the moisture in oil. This is the equilibrium diagram for mineral oil and for ester oils. You can see very clearly the ester oil is figures are shown in they are colored green. And you can see if you take 4% moisture on paper, for instance, I have drawn a line there parallel to 4%, around 4.2% or so. You can see at 4.2% and 70 degrees, you will find that mineral oil, if you see the blue line, that is the mineral oil, you hardly have about 100 ppm, less than 100 ppm. That is the moisture in oil. But whereas in the case of ester oil, you can go all the way up to 950 ppm or 1,000, close to 1,000 ppm. At 4% moisture on the paper, you have got a very wide bandwidth. The bandwidth for moisture, accommodating moisture, is very high for ester oil. That is shown here in this particular comparative equilibrium diagram. So the same thing holds for the synthetic ester. The bandwidth available for synthetic ester is much broader because it can accommodate more moisture. Okay, these are all based on the equilibrium diagrams. Now, this is an interesting graph where, we in our laboratory we wetted the paper. That is, paper was saturated with moisture, and then we tried to see how much of that moisture one can extract using mineral oil in one case and ester oil in another case. The top one is a curve for natural ester, and you can see the paper is completely removed, the moisture in paper is completely removed within 30 minutes. Whereas mineral oil, the lower curve for mineral oil, the extraction rate is very small. The total extracted amount is also very small. So this is the most important difference in chemistry between the two. Now let us see, based on this, a lot of studies have been done on the moisture diffusion coefficients. Ultimately, everything has to be quantified. You cannot just go by saying, okay, I have got an oil which is absorbing moisture and it has got to behave better. No. You have to measure the moisture diffusion coefficients. This is an interesting paper where, the moisture migration from paper to oil was measured. You can very clearly see here, the top line, that is green, is the natural ester, and the bottom one is for the mineral oil. So you can very clearly see that the diffusion coefficients for natural ester is very good. That is, it is the diffusion constants for natural ester is going to be much higher, much higher than the mineral oil. That is, from paper, the moisture is going to migrate much faster in the case of ester oil compared to mineral oil. That is what this slide shows. So this movement is very important. Unless the moisture gets out of paper in time and into the oil, you are not going to see you are going to see a non-equilibrium condition and its effects on the paper and the oil. So you are going to see PD effects, because the moment moisture comes to the paper, please understand this, the moment moisture comes to the paper, it is going to increase the conductivity of the paper. The resistivity is going to go down. So when the resistivity of the paper goes down, you are opening up chances of PD, partial discharge, due to the higher conductivity on paper. So if the transition takes place very smoothly and very fast, as in the case of esters, the transition of moisture from paper to oil takes place very smoothly and in fact very fast in the case of ester oils. And so you are going to see, you are not going to see any partial discharge effects or bubbling effects, and so all the within 30 minutes or so, within a few hours, sorry. Whereas in the case of mineral oil, it takes, even after several hours, it doesn't reach equilibrium. Okay. Now the study on bubble formation at different moisture contents in oil immersed cardboards in natural ester oil. This is a comparison again for bubble formation. All that points to a very favorable moisture dynamics for the case of ester oils. And the bottom line, again, the bottom line is the bottom line of the presentation, which is the ester oil paper system is far superior to mineral oil paper system for moisture management, and it minimizes the probability of partial discharge, minimizes the probability of bubble formation, and oversaturated oil. All these three instances are eliminated by using an ester oil. Now I will quickly go through the temperature effects. The temperature, of course, previously what we have talked about is moisture and temperature both. The dynamics is affected mainly by temperature. But here there is a direct effect of temperature on the transformer, the paper life. The paper degradation and its relationship with the transformer life, the DP200. Here I think it is important to understand one thing. No, we are talking about paper degradation, meaning the aging of the insulation. We all age. There is no escape from aging. But then, the question is, are we aging gracefully or are we aging abruptly? That's the basic question. So here we are trying to, the same thing is applicable to paper. Paper can degrade very fast. That is, you are starting off with the degree of polymerization of, let's say, 1100. And within a few years, if it touches 500, that means it is not aging gracefully. Okay. And whereas in the case of the ester oil, you will find that the aging takes place very, very slowly. So that is again, aging is dependent upon the chemistry, the ability for the oil to take away moisture. This is cellulose paper degradation. Yeah, this is the curve I was talking about, temperature and moisture. You can see how both affect the degradation rate. Paper life enhancement and overloading. This is what you can either enhance the paper life or get an enhancement in overloading. So that is possible because of this is our laboratory experiment where we compare the thermally upgraded paper versus, in the case of biotransol, that is our natural ester, versus mineral oil. You can see the top.
Dr. Saab, can you conclude? Because you are already well ahead of 10 minutes. Okay, just conclude with the 2 minutes.
Okay, I will be done in 1 minute. Okay. Okay, here you can see the comparison. The ester aged paper is, is not degrading as fast as the mineral oil is. Okay, these are all standard graphs which compare the unit life, and that gives rise to the standard where you can see the higher thermal class, 140 for TUK ester oil is mentioned in the standard. Well, the factors, I have given the factors. We have studied the mechanism of how the chemical modification of the ester basically modifies the paper in a unique fashion, and that modification gives rise to enhancement in the paper life So you also have the possibility of overloadability. So the continuous thermal overloading, we have proved by several methods that it is possible to continuously overload a natural ester based transformer. We have carried out joint collaborative work with Crompton that was published in IEEE. So these are so mitigation techniques. I think I have very little time for discussing this. There are 4 arts of insulating material treatment: reconditioning, reclaiming, re-refining, and retrofilling. I think people are familiar with reconditioning and reclaiming, but here I would like to just say something about okay. I don't know what happened. Basically, I'm trying to. Vapor phase drying. I think we are all must be familiar. Vapor phase drying, hot kerosene. Here you have the unique, again, the physical chemistry playing a role. The hot kerosene goes and condenses on the windings, and it forms an azeotrope, and the whole thing can be vacuumed out. Then you've got a hot oil spray, low frequency heating. This is given in the order in which they are effective. The vapor phase drying followed by hot air spray, then the low frequency heating, then the hot air, and the liquid circulation. This is another one which has been circulated using a natural ester to remove moisture from paper. This is another technique which is used. So I think this brings me to the end of my presentation. So I'm not going to take any further time, and I will ask my colleague, Amay, to take over and talk about retrofilling.
So, thank you, Dr. Narasimhan. Basically, it was really an informative and also the fantastic paper, because the timing, what it was been alerted, I am extremely sorry, beg pardon also on this regard, because doctor, whenever he speaks, I also do fear to make him an alert that, sir, please stop there. I am doing injustice. I'm sorry extremely. Once again, beg pardon for you. But it was really fantastic paper. In a nutshell, I can say what is the takeaway. The takeaway is that the kind of moisture dynamics. So each and every delegates sitting over in this forum, please do understand what is that moisture dynamics. If it is possible, till availability of Dr. Narasimhan, you please ask those queries, because clearly he took a point that moisture in paper and oil depends upon the loadability of the transformer. That is the need of the utility's choice. He wants that particular transformer to be loaded as per his or her demand. So that's why moisture dynamics, for that sake, you have to clearly mention the 4R concept. So this is really an informative topic, and also the one, okay, sir, please ask one query, please.
Just one question, Dr. Narasimhan. You talked about the instrument transformer failure because it didn't get enough time for the moisture equilibrium to shift. So when you talked about it, the speed of moisture equilibrium, is it related to the oil and moisture contents? Say for example, if oil content is less than 10 ppm and moisture content is less than 0.5%. This is for a fresh transformer. And when it is say 4% and say 50 ppm, will the speed change? That was my question.
So it's a very good question. Basically, this speed of migration is a function of several factors. Number one, the percentage moisture on paper, that will decide, but that is not everything. We also will have the affinity of moisture for ester. That's the second important point. The third important point is the diffusion. See, when moisture takes place, moisture migration takes place from paper to oil, first it has to diffuse within the paper. That is the that is the slowest part of the entire diffusion process. There are several diffusions taking place, but the most critical diffusion is diffusion of moisture within the paper before it comes to the surface. So that is why you have a lot of time lag. There is an accumulation of moisture at the surface. Whereas this diffusion this has been proved to be very fast in natural ester. Then the oil plays a role in the diffusion of moisture in the paper. That is interesting. That is the most interesting part. So the moisture migration becomes very slow because of that. And once it comes to the surface, ester is able to pick it up very fast. So that is what is happening. And in the case of mineral oil, it has been shown by several authors that it's a slow process. And not only that, there is a hydrostatic pressure. The ester has got a higher density compared to mineral oil. Okay, and it has got the surface tension is different from the mineral oil. So the viscosity is different. So all these factors affect the bubble formation. The hydrostatic pressure, if the hydrostatic pressure is higher, that on the bubble, if the hydrostatic external pressure is high, then the bubble will not be stable. You cannot sustain the bubble. So in different ways, for the PDs, you eliminate PD by virtue of better diffusion rates, and bubbles are removed by virtue of higher hydrostatic pressure and viscosity and so on.
Sir, actually, Dr. Rao, what he was asking, basically the reply what you have given, I think so it was a gap. What I felt, I'm sorry if I just misinterpreted that way, because he asked about the instrument transformer, which is having instrument transformer, current transformer. So during that time, the volume of oil and quantum to the insulations, what it is being considered, I think the transformer, whenever it happens, it is of different way. Of course, anyway, of the way you can have the discussion very correctly. You can discuss very correctly.
Hello.
Yeah. That's what I'm talking about.
Can I have a question,
Yeah,
please?
yeah. Actually, he was with of micless. I'm just explaining the things. He says that whenever the transformer of an instrument transformer, the kind of dynamics is different. So of the line of the we can go for and to have the kind of discussion details. And of course, we are lucky of getting same gentleman from Sabita. So you will be just extending the same where Doctor actually left. You please proceed ahead.
Sir, can I have a question, please? Hello.
So good afternoon, everyone. So
Can I have a question, please? Sir,
Can we take in the last of the session?
not an issue, sir.
Okay.
Not an issue.
Please note it down. All the delegates, please note it down. If also required, please pass on those papers to us.
So shall I start? So good afternoon. I'm continuing from where Dr. C.S. Narasimhan has left, that how the ester fluids is useful in the older transformers, because whatever we have discussed is related with the new transformers, when the transformer is specifically designed for the ester fluids. But is it possible? So my topic of the discussion, so we would like to understand here that as you see from the name itself, that additional life plus safety plus sustainability plus savings is equal to retrofilling with ester fluids. So while giving the presentation, I was thinking this presentation should be dedicated to basically whom? It is basically dedicated to, I can say, see, wicket keepers of the power system. Who are they? They are you. See, wicket keeping in cricket is known as a thankless job. Same I feel it is for you, because you are keeping the system healthy and nobody comes at the end of the day and say thank you to you. So I take this forum to thank you, all of you, that you are keeping our power system healthy and running throughout the year. So please give a big round of applause it is for everyone. So for the copyright purpose, I have not shown the face. Adam Gilchrist, he will not mind. So again, when it comes to the O&M, these are the questions which you may be facing. Any of these questions, if you may be facing, then we should think about what we are discussing in further slide. That you must be having many degrading assets, that you must be having transformer which are 15, 20 years old or more than that, which are now degrading very fast because of the many reasons, because of the years of uses, operating conditions and all that. Then there will be additional load which is keep on adding in your system. So any new machine is coming, any new thing is adding up in your system, in your plant or in your power system or in your overall load in utility. So that all burden is coming on the transformer. Then of course, every O&M engineer always have a anxiety of there should not be any fire hazard or there should not be any accident in the system. Then nowadays there is a ESG compliance. ESG is environmental and then social and governance. So environmental is very important issue nowadays. So many of the comply with the ESG compliance. And then mounting maintenance costs, because as your transformer grew older, it is drawing more and more maintenance. So then what is the solution? I mean, should we just change the transformer or what to do about that? So I want you just concentrate on this particular photograph basically, because it is said that it is easier to memorize something when it is shown in the pictorial format. So these are the solutions actually which the ester fluid after retrofilling will offer to you. First one is definitely environmental preservation, because it is not for you basically, because you are already using all the good things on the earth, but it is for your future generations and their future generations. Then of course transformer fires. Then of course it will add value to your system, how we will see later. And this is a African elephant. What it represents? Basically African element is said that it is one of the longest living mammal on earth. So retrofilling or using ester oil in your transformer will definitely add more life to your transformer. So that is why I have shown it in the form of elephant. So then all is good, but these are the many questions which will come to your, come into your mind. That first of all, is it possible? Right now my transformer is running with the mineral oil and you are saying ester oil, what is that? We know. By the way, how many of you have used ester oil in your system? Please raise your hands. Okay. And how many of you know what is ester oil, or there is a ester oil also as an alternative to the mineral oil? Okay. So this is encouraging for me. So first of all, is it possible? The answer is yes. Then whether these ester fluids are miscible with the mineral oil, because you are saying that you have to remove the mineral oil and put something else, but is it miscible? Because still there will be a residual mineral oil in the system. The answer is yes. Then these ester oils, both natural and synthetic ester, they are compatible with the transformer, all the parts inside the transformer. The answer is yes. Then is it possible to do it at site? Because हमारा transformer तो हमको उधर ही रखना है, ये सब कौन करेगा? So answer is yes. And after all that, your management will ask, you are coming with some kind of proposal, but is this viable? Is this economical? Or is this going to give us some weightage in coming years? The answer is surely yes. So let us see how. So first of all, by picking up from the Dr. Narasimhan's presentation, what we did that how the ester fluid will increase the life of the transformer. Basically, life of the transformer is depending on the life of the insulation paper. Let it be very clear, because inside the transformer there is nothing which is going to degrade except insulation paper and all cellulose materials. So what we did in Savita, we actually did one experiment that we have taken insulation paper, then we dipped it first into the mineral oil. Then after that, we again introduce it into the natural ester fluid, and at 160-degree temperature, over the period of 0 to 275 days, we have observed the depolymerization, because dp value is the indicator of your you say the health of the insulation paper. So the result is in front of you. So when the paper is aged in the transol, that is a mineral oil inhibited, you can see around 101 days itself it is dropping from 200 to less than 200. But when you see the same insulation paper which is already soaked in the mineral oil and again then shifted to the natural ester fluid, biotransol, then still it is retaining its DP. So still it is retaining its property. And that is what is happening when you are shifting or you are changing your mineral oil from, of the transformer to the ester fluid, because it slows down the further degradation of insulation paper, which is going to happen if you continue with your mineral oil filled transformer. Then enhanced loading. So your second worry that my load in the plant is increasing and all load is now shifting to the transformer, and my management is not allowing me, or my management is not giving me purchasing a new transformer of maybe lower rating. So in that case, using the ester fluid, as Dr. C.S. Narasimhan has explained, as also referring to IEC 60076 part 14, with these particular combinations, now surely, of course, your old transformer will be having kraft paper. So if you see the number 4 row, the natural ester with the kraft paper will have the higher, will give you the leverage to your transformer to operate on a higher temperatures. So operating under higher temperature means you can overload the transformer up to certain percentage continuously without damaging your transformer. So that is one of the best advantage you will be getting out of your old transformer when you are changing your oil from the mineral oil to ester fluids. Then of course enhanced fire safety, because ester fluids, they are known as a K class fluid. So as per the definition in the IS 13503, K class fluids is the oils which are having fire point above 300 degrees Celsius. So ester oil falls under that category, whereas mineral oil is under around 160, they are O class. So this particular K class fluid, they offer far better fire safety to your transformer. So they are approved by the FM and UL, and they say in their certification it says that it is 5 to 6 times less flammable than paraffinic based mineral oil. Of course, ester oils, natural and synthetic, both are eco-friendly. They are readily biodegradable, whereas mineral oil is based on hydrocarbons. They are not biodegradable. So any leakage, any seepage in the water, any leakage on the soil, it will permanently damage permanently make the disasters. But in the case of ester fluids, there is absolutely no worry. So return on investments, because if you are doing all this activity, what return on investment you will be getting? So overloading capacity up to 10% more than the rated load, because it is an older transformer, you can get up to 10% more than the rated load continuously from your existing transformer. Then life enhancement. So we can surely say that with those experiments and with our all experience, up to 20 to 30% more life you can get from your existing transformer if you change from the mineral to the ester fluids. Then return on the cost of investment. So it is compensated by first 2 points. Then it is compensated by reduction in the insurance premium if your plant or if you are going with the FM global approval for your assets. So you will definitely get some reduction in the premium you are paying for the transformer. Then compliance to ESG, and then reduce maintenance costs. So how maintenance costs will get reduced? So basically ester fluids, they don't have corrosive sulfur absolutely. So that is why there is no sludge formation, and moisture bearing capacity, as we have seen from the presentation of Dr. Narasimhan, their moisture bearing capacity is very high without degrading its dielectric property. So you can, after checking the oil parameters, you can defer the maintenance activity when you are using the ester fluids. So these are the few are the tangible and few are the intangible benefits you are getting. Now let us see some few technical know-how that how to do it. So these are the few. Of course you can do it at a site when you are using synthetic ester fluid with adequate infrastructure. For the natural ester fluid, the condition is you have to use in the seal transformer. You cannot use in the free breathing transformer. So for that you have, if your transformer is not sealed, so you have to make the arrangements. So it is better to do it at the nearest workshop. Then you have to you have to make it ensure that while removing the oil, mineral oil from the transformer, you try to remove it maximum possible, try to drip it maximum possible, so that there should not be more than 7% of the traces of the mineral oil in the transformer which is remaining. Otherwise, even though both ester and mineral oil is miscible, the composite sample of the oil, its fire point will come down. So that these are the. Then your gasket should be removed. You should change with the nitrile bonded gaskets. Then of course the ester fluids have higher viscosity. So your OT and WTS settings you have to check after retrofilling. Then what support we are providing? So existing transformers, we are measuring DP value, that is blood pressure, as Chowda sir said. Then we are providing necessary guiding and hand holding to our service provider about how effectively perform this activity. Then post retrofilling, we are we are ready to test the fluid in particular period for how effective this activity has happened. And then we have regional tie-up with the service provider. So let us go look at the retrofilling experience. So JETCO was the first utility who has experimented with the retrofilling, that removing the existing mineral oil field transformer with the natural ester fluid. So let us understand more on JETCO's experiment. So I am continuing this with the from Y.V. Joshi Sod. So when it comes to the experience, actually I remember few lines in Hindi. So it is very common. So whenever you are trying new thing, just remember कि I'm switching to हिंदी कि क्यों डरे जिंदगी में कि क्या होगा, क्यों डरे जिंदगी में कि क्या होगा, जो भी होगा तजुर्बा होगा. So we have tajurba. So I am calling Joshi sir to just explain how they have they are having experience with the ester fluid retrofilling. Thank you.
Good afternoon. The ester journey in India started back 10 years back. I think it was 2012 or 13. I don't remember exactly. Dr. Rajaram Shinde approached us with this new concept. Never been with any of the utility, or nobody has tried for this. But after that, the journey started in JETCO, and with the kind guidance and the mentoring, he is also here, Negi sir. We had a long discussion. We had a group discussion. We had discussed with the utilities. We discussed with the oil manufacturers. We discussed with the transformer manufacturers and the testing laboratories. We had 4 or 5 rounds of group meetings also to only understand the what is the ester, how it can be useful, and whether it is really useful or not. So that discussion came to a conclusion that one fine morning a call came from T&R, and today Mamtura sir is also here. So all the stakeholders are here today. That is a fortune for us. And he said that we are going to dispatch 2 numbers of 15 MVA transformers with the mineral oil. So can we do an experiment that we just replace this transformer mineral oil with the esters? So we discussed internally, and we decided to go with that experiment. We decided the way forward, that what we will be doing in that case. So we decided that we will be doing all the routine tests again on the transformer, and additionally we will be doing the temperature rise test with the extended load conditions. It will not be limited to the regular 100 or 110%, but we will go till the temperature rise limits are being achieved. So in that case, we found very interesting that the same transformer with the same design, with the same paper, with the same size, it could take 28-27% of extra load without doing anything. So that is the beauty of retrofill, and that is why we have installed more than 200-300 transformers in JETCO, and this is the benefit we have to encash from the esters, that we can, for the utility point of view, we can say that we can extend the augmentation period. Say after 5 years we are going to augment the transformer, we will be replacing this transformer by say 10 MVA to 15 MVA or 15 MVA to 20 MVA. That period we can extend to 5 to 7 year, 10 year, what depending on the period, the load conditions. So what we did in that case, that was very interesting to know if there are 2 or more transformers in parallel in the same substation, so we decided that we have to retrofill both the transformer, and or either we are be providing new transformer with the esters. We will not be keeping any one transformer with the mineral oil, because we will not be able to get the full benefit of the esters, because one the ester transformer and the mineral transformer both will be loaded at the same sharing. In that case, we will not be extracting more from the esters. So that we decided, okay, in one substation, if we are having 2 or 3 transformer, all transformer will be either ester or will be retrofill. Similarly, we also interacted with the contractors or those who are doing the oil filtration. In that case also, we decided or we experimented on that what kind of the filtering sieve size should be there in case of the esters, because the viscosity is high. So that also we experimented with some of the oil filtration manufacturers, and based on that the cycle is decided, temperature is also being decided, and we also further gone with a step ahead. And initially we started the retrofilling, and we will not be replacing the OLTC oil with the esters. And then subsequently people on the tap changer people, they did the experiments and they come to us and shown their results, and based on that we decided to replace the OLTC also with the esters, and a complete transformer will be a ester field transformer. It is not that we decided to go with the natural or synthetic. It was left to the OEM to decide what kind, but we have given the parameters that after the transformer being manufactured, it will be loaded as the extended temperaturized test. But now comes the role of utility, that after the transformer is being installed, it is being tested and being commissioned, what care we should take as a utility, because that is very important. And because the esters are very hydrophobic, they are the ingress of the moisture is have to be restricted, and whether it is being properly sealed or not, in that case we started that after the transformer being charged, first few days it will be all the transformer oil will be, ester will be tested for the particular parameters for every 24 hours for 1 week, and then after 1 week, every week that transformer oil will be tested, and after 4 weeks it will be done on the monthly basis, then quarterly, and then half yearly. So accordingly we have generated that kind of data at JETCO that gives a confidence at now place that okay, the transformer is running in a desired manner. So that we could do in the JETCO, and we got the full confidence in providing the esters, either new or the retrofill. And because in some cases we also observed that where the transformer not being handled properly, in that case we found the results were deteriorating what it was earlier. So that also we rectified with the discussion with the transformer manufacturer, and now the transformers are being in service. More than 250 numbers of transformers already in service, and there are certain transformers also in pipeline. So I will just cut short here because we are running out of time, because I am also on the other side of this dais. So let us take away that retrofilling is a good exercise. And one more thing I will also like to add here, that we are not restricting only to transformer. Now this experiment have been started to go with the bushing, esters with the bushing, and esters in the instrument transformers.
Joshi sir, actually
are being,
we are running out of the time.
Yeah.
Please.
One minute. So that experiments also we are doing, and let's hope that will also give a good success, because JETCO has started one project. It is called Green Substation, where all the equipments will be green. So let us go with the green. Thank you very much. Thank you, Patnaik Sahab. Thank you.
Actually, we are well ahead of our time allotted for us. You want to ask question? It is no, questions are not allowed for you right now. I'm sorry. Yeah, actually, without the permission of organizing team, also I am declaring one more. The kind of slot been allotted, it is to be extended, and tomorrow also there will be one special session for Dr. CSN. नरसिम्हन सर का एक स्पेशल सेशन होना चाहिए. I am not going to take it, but this is one of the recommendations as the session chair. Can you just imagine, these are the all questions been asked to Dr. CSN. These are all questions. What I am finding here, all questions asked to him only. Another interesting, I think just of anticipating this, Doctor is also there in our last session where question answer session will be conducted. So we are lucky of getting him on the last session. All these queries will be asked during that time. I do not want to take, of course, partiality upon it. Let me take some few questions. Okay, please. Some few queries are been just coming up. Volunteers, please collect those. Now, just of raising hand does not make any sense. You have to write on the paper and to submit us so that we can take up in the last. Okay, please, volunteers, please collect it. Only few questions will take up, but what I hope the queries which has been asked here might be, I think, replied by Patan Sethi sir. So I will be requesting Patan Sethi sir, please just have 5 minutes at least to explain about all these things. Few of the queries will be answered by his extension of addressing to you.
Good afternoon, everybody. It was very nice platform to interact with all of you. I was very fortunate to work in CPRI, Central Power Research Institute, which gave me a lot of exposure where different areas of research and experience was given to me. So that way we are very lucky. Based on that experience, I would like to add whatever the esteemed authors have presented the subject here. I wanted to cover some important aspects about the dissolved gas analysis. This technique is almost 160 years old, and it's a very, very important diagnostic tool. Here, gases that are generated in the oil are being extracted, and then they are separated and then quantified. So this is the work of the gas chromatograph. Yeah. So I would appreciate the Dobel and Mr. Simon, wherein they are looking for the online information about the gases that are generated. Yeah. So that way, it gives a very important information about the status of the transformer, fault condition of the transformer, or if there is any particular problem there, that will be addressed. So that way, dissolved gas analysis is extraction of the gases where we are looking for the key gases. In fact, we are looking for the gases like hydrogen gas, methane, ethane, ethylene, acetylene, and then carbon monoxide and carbon dioxide. So here, the proportion of the gases that are important, and particularly two gases are considered as key gases. One is called acetylene, another is ethylene. Whenever there is a high temperature or high energy discharge there, the gases like acetylene along with hydrogen will be generated. That means something like arcing is happening inside the transformer. And whatever the localized hotspot is there, that is generating the gases. These gases are getting dissolved into the oil, and these are extracted, and we are getting information. The technique is so accurate that we can even detect accurately up to the level of 5 ppm of these gases. So that way, this technique is very, very important. Coming to the components like OLTC. In fact, OLTC is an important device. Unfortunately, many failures are there in the OLTC. Many times we are facing problems there. And here also we can use dissolved gas analysis. Depending upon the number of trippings there, you can find out why the gases are there, how much gases are there, what are the problems there with the OLTC also. Apart from that, this technique can also be used for bushings and other electrical equipments, whether it is even instrument transformers, current transformers, or the voltage transformers like that. So that way, this technique is very, very important. So I wanted to just add on to the points what Mr. Simon has told. Gas analysis is an important diagnostic tool wherein indigenous instruments are there, equipments are there, where we can develop our own analytical techniques and then have something like AI-based systems where interpretations can be easily made. In fact, I would like to say our country is blessed with a lot of talented engineers there. Whatever our Honorable Prime Minister says, we are blessed with the talent, blessed with the resources. Only thing is we are not utilizing them properly. So that way, lot of research work youngsters can do where modern technological developments are there. These things can be integrated into the transformer manufacturing. For example, there is a technique called as thermography. That is, if IR cameras are there, which can give where the temperature is increasing. So that way, if we are integrating these cameras into the transformer tank itself, we can get the clear picture about what is happening, which winding is developing the fault. So that way, lot of research can be taken up by the various utilities as well as the manufacturers, and we can lead the world regarding these modern transformers which can have very easy solutions and have the increased performance in all these aspects. So that way, each winding is having the higher transformer, higher heat, higher temperature there. Just like one of the important techniques, I think there is a startup company called Niramayi, where a simple thermographic system has been used for the detecting of the breast cancer. Similar techniques can also be used in transformer where the winding temperatures and profiling
Patan
can be
Sethi sir,
done.
can we conclude because we are already from time.
So I'm sorry, actually I had to complete a few more points only. Then coming to the other aspects, we are looking for the environmental aspects. In fact, we worked in a important area called as polychlorinated biphenyls, ascarols. In fact, many of our senior people will be knowing that we were using a fantastic liquid dielectric called as ascarol. It was working very well as a dielectric, but unfortunately it is a persistent organic pollutant which can be there in the environment for almost about you can say 500 years. So that type of material is hazardous for the environment. It can go into the body and create cancer and other problems. So environmentally we should be very sensitive not to use the environmentally hazardous materials in our electrical engineering domain. So that way we request people to see that we are using eco-friendly materials in all our activities. Yeah. So coming to the ester fluids, in fact, it has another dimension. Being an agrarian country, India can produce indigenous ester oils. So that way, our foreign exchequer and depending on the other countries for the petroleum crude will be reduced. So there also we can do wonderful work, and esters are definitely good. Again, there are some challenges, we have to address them also. Something like maintenance of these transformers, about something like oxygen availability and the degradation of these ester oils. So these challenges also we have to take up R&D programs, where we have to see how best we can maintain them. And our country will be definitely benefited by using the ester oils. So that way, another area I wanted to tell is...
Sir, sorry to interrupt.
Yeah.
Sir, sorry to interrupt.
Yeah, yeah.
Because you are giving very good information and people also want to, are very eager to know. They have given questions, you know. If it happens in question answer session, then it looks good.
Fine, sir.
Okay, now the time is like, you know, we have to break for tea and we have to come back again.
Yeah,
So
yeah, you are
please,
correct.
please take only 1 minute and please try to wind up.
Yes, sir. So that way, one more area is where we have to develop the core material. Transformer core material is not a high-tech area. In fact, the various organizations have to work together and work for the development of this material. Apart from that, I am also requesting our agencies or government authorities to develop something like a knowledge domain, say repository wherein all this data can be saved, and by using AI, we can make this available so that all the engineers will be accessing the data and use it for their operation and maintenance. Thank you. Thank you for all.
It is really interesting. I am, with a very quick note, I will be completing. I'm not going to also summing up all these things because it is clean and clear of explaining all these things. Do you just believe what is the, this piling of queries are there? Of course, I will tell you one thing, one more thing also I will tell you.
Patnaik Saab, but I have one observation. There are so many questions. We have completed more than half a day and the delegates did not get an opportunity to speak. You know, in the beginning only we discussed that the presentation is for setting the context. You are giving information, but if the information is associated with some genuine question, the same interaction can happen. So my sincere request to the speakers and the future moderators, let us, like you, after your presentation 5 minutes, please wait for 5 minutes and ask that, okay, is there any question till this point? It is not necessary that we complete the entire presentation. Even if we discuss couple of slides and there is more interaction, that will be very useful. So I'm sorry for this interruption, but because the questions are piling up, and tomorrow also if the same thing is happening, then the Gyan Sabha is really not happening. It is only Vani Vilas happening. Okay. Thank you.
No, actually we are, with due honor, we are accepting these suggestions. Only one point is that it was not been taken up in a correct spirit whenever we started the session. Otherwise, we could have managed the things in that, managed the show in that way. But we are lucky in one aspect, I can say. Organizer already just anticipating that it will be asked the maximum queries to Dr. CSN. He has kept in the last session as the question and answer session and all. Only one thing we can do, as it is the session for the house, people to speak or the audience to speak or the delegates to speak, we will be giving them chance to speak in this manner. But time is very short, posit of time. We are not going to take up the suggestions what right now extended by Jagdish ji. But it will be taken up definitely hereafter the things whenever to go up. But only one more way I can say, there are some few questions out of course also came here. Out of course question also came here. So that indicates what is the interest you have. So I will be requesting one sincere request also. Please be on the last session tomorrow. We are going to be discussing giving the real justice to each and everyone. In case not, then I will be requesting also, I think Savita group of people are there. The queries what you have asked very correctly with a smooth way, Dr. CSN will be replying to you. It will be reaching to you also. Don't worry upon it. So with this we are concluding. Of course, we will be giving real justice to your queries what you have asked, but not possible to discuss right now. So we are this way, please.
These are not the questions, it's my observation. You know, somebody asked about the cycle of the oil filtration. Is there any, what should I say, guideline for using the filter machine for a particular job? So if the transformer has 100,000 liter, 1 lakh liter of oil, and if you are filtering it with 500 liter per hour oil, it will not work. So, is there any guideline? I don't know about it. So that one question. And another is filtration of the oil. How should you do that? One is that you use the machine and continuously filter the transformer oil in the same transformer. That will not give you the result very quickly. But if you do otherwise, like filtering the oil in a different tank, emptying the transformer, and then filling it back, it will give you better result. That one thing. And third thing which I have is most of our transformers, we are loading only up to 40-50%. Never more than 60%. In the worst of the cases, it may go up, but it is in a very few cases. In that case, the aging of the insulation is relevant or not. So these are the basic things. We need to load our transformers fully. I request all the utilities to load their transformers fully. We don't unutilize the capacity of the transformer. And moreover, when you load the transformer with a lower load, the power factor also decreases. So you have to also see that you are increasing the load by loading it fully. You can go up to 90%, 100%, why not? So we should do that. And then, we can think of using ester oil, though the purpose of the use of the ester oil is environmental issues. But otherwise, for temperature rise and all that, we don't have to use it because we are underutilizing our transformer, and we have to just see that we load our transformer fully. I'm sorry for intervening in this thing, but I felt like, saying this. Thank you very much.
Thank you, Mumtaz Sahab. Thank you for the great insights. We do agree with you partially. Okay, so the time is for the felicitation by Chairman. So may I request Chairman Sir to felicitate all the authors. We start with the logical order. Please. Mr. Y.V. Joshi. Mr. Ame. So finally the session was Eastermay session. Mr. Patan Shetty, please. Mr. Patan Shetty being the co-chair of the table, we could not get much time to introduce and may I request Mr. Mamtora, please felicitate to our chairman, Mr. Narasimhan, please. Narasimhan. Mr. Patnaik. Oh, no, we check it. Yes, Chairman sir, please be there. He's already there. As most of us know, the T&R, so we are lucky to have him here. Great. Thank you so much. And now please be there for the group photo. All the authors, please come forward. Mamtar sahab, आप वहीं पे रुकिए एक मिनट. एक फोटो के लिए.
Hello. After tea break, there is an interesting presentation by Dr. Aradhana Ray. She is having decades of experience in testing and commissioning, and she provides consultancy services. Those are top level consultancy services. This is a very excellent presentation. I want to request you, I'm asking you a question. Would you like to take a tea break and come back, or you want to continue? Those who want to continue, raise the hand. Okay, thanks. And it will be interactive session, and I give you the promise that the question answers we want to continue will also be continued. Those who do not like, if they, for any reason you want to go out for, you can go out, okay? Yeah.
So
we will continue with the presentation.
2 minutes. Can I, with your permission, yeah? We are talking about, Dr. Narasimhan talked about the migration of the moisture from insulation to the oil. And can we do something like when we have very old transformer, we fill it, we remove the mineral oil, fill it with natural ester, and after loading it, after the moisture comes out of it, we remove the ester oil and put back the mineral oil. Can we do that?
Sir, I have just one query. I'm not expert in that field. If you want to retrofit with ester oil, I think the air cell conservator is must. We can't do with the free breathing transformer. Air cell breather is must. We should not do with the free breathing transformer. Retrofitting. Yeah. Yeah. Fill it.
Okay, now I believe the session is a hybrid session. The hybrid session means people who really want to have tea, they take the tea and come back to the hall. This is going to be very interactive workshop. I would not say only presentation one way. And Dr. Aradhana will start her interactive session. And I will request people who have gone for the tea, please come back fast, and we are starting the session continuously. After this session, I will definitely like to answer the question what Mr. Mamtora has raised. Thank you. Dr. Aradhana, hand over to you, please.
Yeah, I'll try. Actually, expectation is very high. Let me see. Slide, please. So, we are going to discuss about the latest diagnostic tools which we use as a part of the CBM. And they are not the very old, not the very latest, but the established technology which has advantage, and we can go to the component-wise detection of the problems and solving the problems of the transformers, any kind of issues very fast. I have suggested this. Okay, next slide. Yeah.
What is exactly? You can use this one also.
I can. But I can't see my screen. That is the problem.
You're not able to see.
Yeah. Can you shift it?
यहाँ पे करो?
नहीं, can you shift it?
नहीं, उस तरफ.
Yeah.
Is it fine?
Yeah, it's okay.
What happened? Actually, we are inviting Mr. Patan Shetty on this. He's a session. I think I don't know, but if you're okay, so we can just wait for
Mr. Patanchit. Sir, I would like you to please join Aradha ma'am on the dais, please.
Okay, so we'll continue. So what we find that very old assets are going well. We have a history that 60 years old, 80 years old transformers are performing very well. But the new one can give the problems also. So identifying the trend is very important. Actually, I'm not able to see my slide and not able to adjust myself. There is a big issue. Okay. If we see the transformer as an asset, it has a lot of sub-components. And all sub-components quality, its quality matters, and we have to go to the sub-component levels if you want to identify any problem or any premature failures in the transformer. Okay, so we'll go directly region of failures. Region of failures is not that it start after some aging process. We'll validate this by, with lot of examples also. So it can happen some kind of failures at the design and manufacturing quality stage. It can happen at the transportation stage. It can happen during commissioning stage. If you have some frequent system failures, then also it can happen. And how will you maintain your transformers in your system, like fault feeding and all? That is also very important. So, during factory test itself, we recommend to have some special test and benchmarking like FDS, where you measure the moisture. Then you can have your own limit about the partial discharge, not go as per the extreme limits of 500 PC like that. Then no load test, it's very important to have a harmonic content. Then in temperaturized DGA is must, we should have. And then when you are charging the transformer reactors, thermography, sound and vibration level test, and SFRA also must. Now, these are the cases I will discuss which is related to the transportation. That means transformer is dispatched from the factory to site and we are facing issues, and how we resolve those issues, those cases I am going to discuss. Case 1. Specs. 160 MVA transformer. Rating is 220 by 132, that is auto transformer, and what we are facing here is the impact recorder reading, which was giving 7.7 G in the Z direction. Means the base value is 4 G if you look at the impact recorder reading, but it is 7.7 G. That means we know that transformer has gone through some kind of vibration or kind of jerk during transportation. Now, the first thing which is established, what could be the reason for this high G, that is oscillation in the Z axis, is by SFRA. We all know SFRA. SFRA is just a fingerprint of a transformer, and you can either do the three-phase compression or you can do with the base measurement. It's a fingerprint. Basically, you are taking across the frequency domain and you are plotting dB versus frequency or phase versus frequency. So, what is the significance of SFRA? Basically, SFRA is a tool where resistive, inductive and capacitive, all the components together is going to give you a fingerprint. That means indirectly you are monitoring your resistive component, inductive component and capacitive component. Resistive component means directly you are related with your conductor. Inductive means mutual inductance and self-inductance. Capacitive means all the insulations you can assume your transformers like interwinding insulation, interturn insulations, or tank to winding CH insulation, or winding to core CL insulation. All those insulation comes in the picture. So indirectly, if you are going to measure all this RLC, indirectly that means any problem in your transformer, either mechanical, electrical or dielectric, you are going to capture by SFRA. That is the beauty of SFRA. That means you have taken a fingerprint and you have some value of RLC, but the condition changes due to transportation, due to fault, due to anything, then this RLC parameter is going to change and that will change your fingerprint. Once your fingerprint is changed, that means there is something which you need to validate. Now, in this case, what we find that the mid-frequency variation is there in the SFRA. Where is the pointer? Pointer. Which one? No. It will not. Okay. Here it will allow? Okay. So what we are seeing a division in the mid-frequency when compared with the base value data, the red and the green one you can see here. So there is a deviation both in the amplitude and the phase. So based on this and the G parameter, 7.1 G parameter, that means there is a mechanical shift and SFRA validated there is a mechanical shift. Based on that, the transformer was open for inspection before having a detailed commissioning. Once it is arrived at the site and we suspect this is a problem, so it was open for inspection, and what you see here, that clamping support structure has already shifted. It's not in a normal position. That was one indication. The other indication was a lot of nut bolts and the structures were loosened from inside. That means it is something that on site you cannot tighten up and say that transformer is okay. It has gone through the major shift. So the decision was taken to take this transformer back to the factory. The reason was it is a kind of transformer supplied in a fleet. So if one transformer is not performing well, you can always have some kind of arrangement. It's not so in a hurry. And second thing, if you charge the transformer, okay, your voltage, current, everything will be normal, no problem with the transformer. You will see a good parameter, but the life of the transformer cannot you expect 30 years or 50 years because it is mechanically weak. So one or two system fault is sufficient enough to collapse this transformer and giving you a life which is very less, even 5 to 10 years. So the technology has gone to the extent and the kind of confidence is there that what kind of action we can take on time. So this is the one case. The second one, this is a GT, okay, and again we see that the vibration is oscillation is much higher in the Z direction, 10.1 G, okay. And what we find that some loosening of the nut bolt, it's not major, not at all major looking at the 10G, okay. But when we compared, what we find, it looks very normal. SFRA plot looks very normal. So that gives a message whether the oscillation is 10G, but the making and the quality, manufacturing process and the quality of transformer is so good that after 10G also, the whole core coil assembly is very much intact and there is no need to have any kind of such proactive action at the site to tighten or to bother about this transformer. Although it is a GT, but looking at the SFRA result, this transformer was commissioned successfully and still it is running. So that is the benefit.
Madam.
The third case, after this case I'll stop.
No, means ask the questions.
Yeah, I'll ask question after this case. So third, again, it's a 36 MVA transformer, industrial transformer, and again, before transformer and after transportation, we have fingerprint. And this fingerprint is slightly confusing. As you can see, deviations are there in the HV plot also and the LV plot also. And deviations is like that we concluded that something has happened in the neutral connections. It's not that all winding is bad, HVLV winding, it has something happened at the neutral connections, and that suspect was true because again this has come because it was on LV side, nothing can be done at the site, it has come to the factory, and what we see, the support for the leads are not sufficient, and during transportation the lead has come down because supports are not proper, and these are the 90-degree bend. If you look, if you keep such 90-degree bend without sufficient support, it by design itself is not good for the short circuit withstand capability. So again, retightened and all the supports were given, and this transformer was corrected. So now this is just one case I discussed about the transportation. Any question? Sorry, I'm not comfortable actually. Normally I give presentation by my laptop, so this is a different arrangement. So, but now I am settled, no problem. Yeah, any question regarding SFRA? Because I just talk about SFRA right now.
Hello, ma'am. Can you explain the by signature test which portion of the winding is disturbed or something? Whether it is in tapping side, whether it is in lead side, something.
Yeah,
Yes.
yeah, I'll do that. I'll go to the healthy one, so it will be easy to. Sorry. Yeah, this is a normal SFRA plot, but unfortunately I don't have, but by the frequency band I can tell you. The pointer if you have, you can give me. Nahi hai isme. So what you're seeing is the first resonance. By the time they arrange the pointer, I'll explain the first resonance that speaks about the core arrangement. What you have the core clamping arrangement, it talks about core clamping arrangement. That is the first peak. Any SFRA plot. When you go to the second, third, fourth peak, there is a self-inductance and the mutual inductance which is predominant. Which one? Dekho. Yeah. Anyway, so the second and third peak is talking about the self and mutual inductance and the interwinding capacitance of the transformer. That means any movement happening between the winding, okay, major shift will be reflected here. So very important from the mechanical aspect of the transformer. And the last one, what you see is a overall shift of the core coil assembly, the bulk movement, and the tap lead or the winding lead or the bushing lead, any lead play a role there at the high frequency in nutshell. Yeah.
Any other question?
Ma'am, one question.
Yeah.
During transportation, impact recorders are also provided on the transformer.
Yeah.
Have you seen the analysis of that impact recorder?
I have analyzed some of them. The data has came to me, but why this particular question I didn't understand.
So can it indicate about the transportation, how the transformer was transported? Was it in?
It is with respect to time. Okay. The impact recorder, the waveform is with respect to time. You can see at what time what could happen. That detail also you can get from the impact recorder.
And other thing regarding SFRA.
Yeah.
In the last, at the end, at the high frequency, the lead portion covers, which is generally not matching at the site. Sometimes it mismatches.
Yeah.
As compared to the factory test results. So is it acceptable or not? And how
no,
much is
you
the
have another criteria to evaluate that, because site condition could be different from the factory condition. Say bushings could be different. What you have a bushing at the factory can may be different than what you are having at site. Different conditions are there, but you can do three-phase comparison and come to a conclusion. I am not talking about the minor deviation. I am talking about the major deviation, which could be established when you have it on lead side.
Generally same bushings are used at the factory test and at the site?
See, it depends because I also worked by, I mean, when I was an engineer, SFRA is my PhD. Maybe I have done more than 100 transformers in 2005 and yeah, 2005 to 10 era. So these are hypothetical that it doesn't match or nothing will happen. You have to do the proper arrangement, proper lead, proper earthing. 90% correlation is there. That much confidence I am having on SFRA.
Thank you. Sir, this can be continued after discussion? We should go for next question?
No, it's okay. We can go to the next.
Sir, this can be discussed after the, if you don't mind. Any new question? Okay.
Ma'am, here. This regarding SFRA, will there be any difference in SFRA if it is done with oil and without oil, or is it recommended to do it with oil only, or any differences it will be there?
See, with oil is a standard test, we should do it, but why we are doing without oil is a different story, because when you're transporting the transformer and you want to match it with the factory fingerprint once it reaches at site, okay, and if you're done without oil at factory and at site, matching is very easy. If you're not doing it, suppose you did with oil at factory, without oil at site, there is a deviation, and that deviation is consistent because the capacitance of the insulation has changed because oil is not there. So it's a consistent change which could be evaluated that this is not because of any fault, because you don't have oil, so the shift in the SFRA plot is there.
Can that be identified like this SFRA has been done without oil and this SFRA has been done with oil?
Yes, yeah, very much, very much.
Okay, means potential shift will be there, or?
Yeah, because your C is changing, no? Your C is less, we don't have oil, and C is more when you have oil. So F is what?
Yes,
1 by LC, no? So it is well established.
That will be an uniform impact.
Shift, yeah.
Yes.
Uniform shift, yeah.
Okay, fine. Thank you.
Yeah, hello. Yogesh from Torrent Power, Ahmedabad. Suppose my transformer is old and I don't have any reference plot of SFRA, then how can I conclude that this is normal?
You don't have any reference plot of SFRA,
yes,
but
yes.
you want to establish that your transformer is normal.
Yes, yes.
There are 2-3 ways to do it. Suppose in your system you might have 2-3 sister units. So you can well compare with them. Sister unit means same age, same make, that way. Or if you don't have anything, then 3-phase comparison is good enough to give a fair idea that no problem inside the transformer.
Okay.
Hello,
Yeah.
ma'am. Madam, we have at our substation we have a GIS transformer where the GIS ducts are directly coming on the transformer itself. In the factory, normally the GIS means the SFRA testing is done without GIS duct, and so the SFRA graph is different, especially at high frequency. So, is it okay that suppose we are comparing face to face, means if the face to face is matching, means say RYB are matching with each other, then can we conclude that because I think GIS ducts are making some effect on the SFRA results?
Sir, you answered yourself because your signature is different than the site signature. Now you have a base signature with you. And whenever you do after 5 year or 10 year as a CBM, or if you see some fault, just compare it and see that any deviation is there. It's fair enough, no problem. And 3-phase comparison is always there as you are doing it.
No, means my question is.
Yeah.
My question is that SFRA results are at site, means with GIS duct are not matching with the factory.
It will not match, but because the circuit is different. It's a RLC circuit. If you change the circuit by any way, your plot is going to be different. So it is justified, it will not match. But once you have a base plot and you're comparing three phase, it's fair enough. You keep as a base plot. We can't do anything about that, but good that you're having that practice, and with GIS and with all the bus bars you're taking, that's a good practice.
Okay, thank you.
Just a small reminder, whoever gets up and has a question, please express your name and your organization so that people can connect with your question. Dr. Aradhana, I have a small question. I really don't understand much about SFRA, but if it is, just to clear my understanding, if it is to establish mechanical healthiness of the transformer, have you experienced any example where the out of a fleet one transformer where SFRA has been monitored and it has given X life, whereas the another transformer where SFRA could not be monitored and it failed because of short circuit or mechanical sturdiness has been disturbed? So have you come across any of such practical example in your life?
Yes, so many. I'll discuss in the case study. You'll see that.
Perfect. Thank you so much.
You.
Good evening, ma'am. I am MV Sudhakar from Jindal Steel and Power. Suppose I received one new transformer, 120 MVA from factory. If I conduct all the low voltage test, after that, if I provide that SFRA, is it okay? Or some high voltage test, that means SFRA is to be conducted before high voltage test only. Is there any condition for that?
Very good question you ask me, and I'm delighted to answer that. There is no such foundation that DC test is done. We should not conduct SFRA. We need to demagnetize and then do SFRA, because there is a relevance why I'm talking about this. What happening if you are doing some DC test?
Yes,
either
yes.
IR test or winding resistance. Okay, your core get magnetized. You will have some deviation in the core portion, right?
Okay, okay.
But the core portion where you are seeing a deviation is nothing going to contribute in SFRA interpretation. So in low frequency area, we are seeing the winding, and winding is very much visible in the short circuit plot, and we are able to interpret it. So if my core get magnetized and I'm getting deviation in the low frequency, no need to bother about that. Just continue. Don't make it is a very fancy tool and something like that. Okay, so much precaution you have to take. That is how the lot of method is evolved in SFRA, how we interpret. So in low frequency, open circuit plot, we are not seeing as a part of the interpretation. We are seeing the short circuit plot, because there I am getting the inductance portion. So it doesn't matter what you do and when you do.
Okay.
Yeah.
Thank you. Thank you.
Hello. I believe someone has a question. So once that is done, someone has a question.
आपने तो सही ज्ञान सेवा कर दिया ये मेरा प्रेजेंटेशन कितने घंटे में खत्म होगा मुझे नहीं पता.
Good evening, madam.
I'm comfortable.
Yeah.
Yeah.
Madam, I just want to know, I am from Snyder Electric, myself Somnath Chattopadhyay. I am taking care of after sales service.
Your good name?
Somnath Chattopadhyay.
You are my college senior. I know you very well. Yeah.
But today you are expert in SFRA field. So
No, still I am junior.
The one question, but is there any change of SFRA interpretation if the dielectric medium change in site? Suppose we are sending a empty transformer to the site, we have done SFRA with some another quality of material, oil quality, but in the site different quality oil change. So it affect the SFRA interpretation.
Sir, any dielectric change, whether you change oil or whatever you change, bushing, whatever you change, it is going to affect your SFRA plot. But as you said, you know what you have changed. You have changed the oil.
Yeah.
So one dielectric parameter has changed. So that will have a uniform shift in your plot, and you are able to conclude that there is no problem in the transformer. This is because I have changed the fluid. Even you can calculate. I have calculated the frequency shift also depending on the dielectric permittivity, and it will give you the result, and you can validate that because of this change in the fluid, this is a shift in the SFRA plot.
Thank you very much.
Thank you.
I think we have done 35 minutes here. I will request Dr. C.S. Narasimhan to join on the stage. Dr. Aradhanare will continue the case studies, and then we will have question answer where some questions can be asked to Dr. C.S. Narasimhan also. Mr. Dr. C.S. Narasimhan? Ma'am, please continue. Sorry for this informal adjustment.
No, it's okay for me. Okay, no issue. So now those three were about the transportation of the transformer. This is about the aging of the transformer, how SFRA can capture the aging. So this is the SFRA plot, compared three-phase, and it looks abnormal. Three-phase matching is not there. And when the transformer was, it's not just SFRA here to make you aware. I've just shown the SFRA plot, but the DG history was very live, and it was showing the hotspot in the core. So it was established there is some issue, hotspot issue in the core. But as a backup, we did SFRA and we find such kind of major deviation. So what you are seeing is a hotspot in the core, and that was rectified. Now, there are some suggestions here. During commissioning, first thing, the inspection plan at the factory should be very exclusive and in the detail, with stage inspection and some customer hold points. If you want really a quality transformer, that is something it will add on. Then standard procedures and formats to record the data once it arrives at site. Utility has, but not all the utility has it. So if you have your own standards and procedures with the benchmarking of the data, what you accept when you receive at site is very good to have as a procedure and the standard. Then moisture measurement, FDS at factory, if you do, very good, because life of the transformer you decide once you dispatch from the factory. As we are talking a lot about moisture here, it's good that when there is a moisture, we are trying to find some solution, okay? But once you have a benchmarking at factory itself, this is my moisture content, and this is how dry or wet transformer we are taking from the factory, is give you a thumb impression that we should not bother about the moisture most of the time. We should bother about the other problems. So one problem can be solved here. And then rigorous monitoring of the equipment immediately after commissioning, like thermography, DGA, partial discharge, vibration, noise, till the transformer gets settled down. Once the fingerprint should be there, so that is also, because infant failure is very much prevalent in our system till the transformer get acquainted with the system and get settled down. It could be some commissioning error, some component issues, so those could be identified, some structural problems, some kind of teething problems could be identified. So online monitoring by these techniques is very helpful once transformer is charged. Now this is a case which is giving a failure in the short span of commissioning after 2-3 years. What you see is a 10 delta value here, 2.6 or 1.8%, the moisture value, and the 10 delta is also on higher side. Normally for the good transformer and new transformer, 10 delta benchmarking is 0.5% maximum. But here the 10 delta value is on higher side, and the FDS benchmarking is good for 1%. But here the those values are very high. So what FDS, frequency domain spectroscopy, which measure the moisture content in the winding, any OIP insulation, winding or bushing or any insulation CT, it measures, that means directly it measures the moisture content in the paper insulation. Okay, so when you measure the moisture content in paper insulation, you are done with your measurement, because oil has very less moisture. Whether it is a ester-based oil or paraffinic oil or naphthenic oil, it has 1% to 3% oil in itself, but the reservoir of the moisture is paper insulation. And there we should have more care than talking much about the moisture in the oil. So once this is confirmed, like what you are seeing here is a standard, very standard, standards are there, IC, IEEE, SEGRE, and all are having its own benchmarking, and from there this is a derivative that less than 1% is good, 1 to 2% is dry, and 2 to 3% is moderate, like that. It is defined in different standard. So, So there is a case where everything is okay, transformers looks good from outside, but we know that the moisture content is high and it's 2 to 3 years age transformer, not more than that. And at the last stage inspection, we find rusting in the transformer, and this is basically because the moisture content was high and it was giving such kind of problems. Now what DFR, FDS, what I am talking right now, is moisture in the insulation, it measures, that is one thing. If you have high oil conductivity, that means without taking the oil sample, you can measure the oil conductivity at site. Aging or overheating of the cellulose, that also you can see by having all the test parameters, dielectric parameters, and contamination of the winding. That means the winding is deteriorating or having some kind of partial discharge or having some kind of tracking, all those contamination could be assessed by DFR. So like one measurement here, what you see that everything is good, 10 delta is good, moisture is good, but the conductivity is high. It's possible because conductivity is nothing to do with your moisture content. Conductivity is a different dielectric parameter, moisture is a different dielectric parameters. But here the clear indication is there, okay, your conductivity is high, but your moisture is in control. So what you are seeing that if transformer is designed and there is no stress, it can age very nicely, having a good strength, that means DP value will be very good. But because you have different constraints, system transients, like you have, we say that short circuit forces, we have thermal stress, we have mechanical stress in terms of fault, we have moisture as a dielectric aging parameter. All those things reduce the withstand capacity of the insulation, and that is how you reach to end of the life. And we define that there is a life of 30 years, 50 years, whatever, depending on the application, where there is a generator or it's a transmission unit or an industrial unit, we define the residual life of a transformer. So what we are seeing here is a transformer which is having a storage of 3 years, and because of bad storage, it is nitrogen filled, it is not oil filled. Normally after 6 months we should be filling with the oil. We should not keep so much time for the nitrogen field if there is a delay in the commissioning. So the moisture content is high. It should not be like that. It should be below 1% or 1 to 2%, but high, because it has absorbed the moisture, because it is not filled with the oil. So that is what. Any question till that? Then I will go to the partial discharge.
The concept is more question and answer, and there is no need that we should complete the presentation. We can leave the presentation in between, okay?
No
so
issue.
with your permission, ma'am, we can continue the question and answers.
Huh?
And
Yes.
question can be asked to Aradhana ma'am, Mr. Pramod Rao, the bushing topic or oil topic. You can say, you have to give your name, your company name, and the question is directed to whom, okay?
Myself Manish Pandya, MECPL Baroda. Madam, can we have a clear idea about magnetized core and double ground in a core by just doing SFRA?
Magnetized core will have a different pattern. Double ground core will have a different pattern. So
But then is it available anywhere in a database where we can match? Because at site there is no provision to match the signature.
Yeah, yeah.
So we can have idea about the core, that there is problem in a core.
Double ground could be identified once you do the CFT measure, right? If you have some double ground, you will not get the measure of all three components. From there itself you can identify if there is a double ground. So, two problems are different problems.
Okay.
Good afternoon, ma'am. Jimit Patel from Opal. I have a question regarding SFRA. We have 12 years history of...
I am not able to identify you itself.
Yes, ma'am.
He might have reduced 20 kg. Clap for him. Before 1 year I have seen him and now I am not able to identify him. Yeah, please. Sorry.
We have transformer from last 12 years.
Yeah.
We have done SFRA in just 1 year ago, and there is no any problem in. But I have a question regarding frequency of transformer testing and SFRA. In which timing period we have to test?
Very relevant question. SFRA should be done during the commissioning and factory. That is what you have done. There is no need to do the SFRA every year or after 3 years. But once the transformer has seen the fault and the quantity of fault, quantum of the fault, 10%, 20% of the dead short circuit capacity. According you take a decision when you want to do. Suppose you have a small fault of 20%, 30%. So maybe after 4 or 5 feeding of such fault, we should conduct SFRA.
Okay. If any, there is signature.
No guideline for such.
No
guideline for such thing. Yeah.
Okay. Thank you.
Good afternoon, ma'am.
Yeah, good afternoon.
Myself, Satish Raut, Executive Engineer, MSc TCL. What is particle count test? Whether it is necessary during the commissioning of a transformer or reactor? And second question is, how do that tan delta gets increased within a period of 1 month from the date of commissioning? If all the factors after testing remains unchanged, normal, only tan delta finding gets increased, and it got increased up to 5%. 0.5% or so.
First thing, particle count. That is something very latest thing we are doing. What is happening when the transformer get processed during commissioning? There is a chance that some copper particle or some CRGO metal particles or anything, metal particles could be. During filtration also it's possible that something can happen. And normally in 765 kV and 400 kV there is a norms, okay, 2 microns and all. So when you follow that, it's good for you because once the particle count you are doing and you are improving your filtration process and achieving a value as per IS 2 micron value you are achieving it. It is removing all the particles, foreign particles. When it is removing from your transformer, you have very less PD level. Partial discharge level is very less. Your tan delta also going to improve. And these particles get charged when you are doing any process. It gets charged and get accumulated at the metal points like OLTC contacts, leads there, it get deposited. So it should not be there. If possible, you filter out so that in future you are preventing your transformers from any dielectric failure. And plus sludge formation is also one chance which can happen. So good, we are doing particle count and we are trying to remove all those foreign particles which can happen during the process of commissioning. Your second question was regarding tan delta. It is very subjective. We can't discuss right now because in 1 month it has changed. Something might have happened which we have to look whether system fault is there or some process you have done or whatever it is. It's unnatural. It should not happen. So it's a kind of investigation we must do.
Dr. Aradhana, if you have permission, can I take this question I have a relevant example. Yes, gentlemen. So, the particle count being a favorite subject nowadays above 400 kV, the transformer OEM, again, Mr. Mamtora is also sitting here because we recently had the same issue. And end customer or OEM, that's a Power Grid Corporation, we have some people from Power Grid also here. There was a issue when they, I will not say issue, there was a concern when they were installing first 400 kV 50 kVAR reactor in West Bengal that was manufactured by T&R. So, okay, thank you. Okay, so the concern was it was failing. The statement I received as a mail, they think I was a little expert there, so that's why they sent it to me. I may not be. But the concern was the transformer fail in a particle count. And the particle count, the word itself specifies the definition, particles present in the liquid. So that can be conductive particles, non-conductive, insulating, non-insulating, whether Madam said, let's say sludge, at early stage of a transformer, I will not call sludge, but in case of natural ester field transformer, you can say those are oligomers, it's early stage of gelation. Or the worst part is when the accessories like radiators are manufactured, they are seam welded. And even though those are flush, clean, there are some particles which are inside the radiator, and during the assemble they get, after some time they get mishandled, and that particle comes in the liquid. They get deposited at various places of the winding, and they lead to some issues which can be partial discharge, which can be tan delta, which can be any other concern. And only way to remove it is by filter mechanism. There are no other mechanisms as of now. And after doing 10, there was some question somebody asked, my friend from Bihar, I think, or he said, how many hours I should do filtration. It's not important that how many hours you do filtration, with what size of filter you are doing filtration. And this is live story, that's why I am sharing, and the data is quite available to share, and nothing secret into it. The guy who was doing a filtration was having a filter of a first stage filter was 40 micron, and second stage filter, which are nowadays candles, these ceramic filters are very common, and the second stage filtration was 10 micron, and their expectation was the particle count less than 0.5. So then the answer, when we did a detailed analysis, the answer was hidden into their problem statement itself. Without doing anything, we just sent some sample from Pune. There is a company who makes filter machines in the Pune. So we took some samples of a 0.5 micron from them. 4 candle. There is also a big subject that what is the absolute filter and what is a filter. So 99.99, so what particles it allows. Again, it's a separate subject. But the filter cost varies between absolute filter and regular filter is as different as 200 rupees and 2000 rupees. Both looks identical, both are same in the size. So we sent the filter, we just did one pass of 4 hours to answer the question, and then it passed. It passed all the tests, and the transformer is probably India's first 400 kV transformer running with Ester, and it's running successfully. The second related question to it, when you are allowing impurities inside, those can be during the manufacturing, some dust accumulation is there. During the handling, when you ship the transformer from one place, we do fill with nitrogen, but whether the nitrogen is pure or not, in the cylinder, do you have any contamination? Everyone who fills the cylinder with nitrogen gives you a test certificate, but it depends because that's very roadside and a small industry nowadays. So the authenticity of TC also needs to be verified. These are all small issues, but when you touch upon that subject, that needs to be in-depth, even it is a small issue, but needs to be in-depth studied. If it answers your question, thank you so much. Sorry, Pramod Rao want to have something.
Mr. Pramod Rao will have one question. After that, we will have last question. Is there any more question after that? We will have this last question. Okay, thanks.
I'm not asking a question. I am only replying the particle count question. The gentleman who asked the particle count question, actually, you know, there is a very nice SIGRE technical brochure on this. I do not recollect the number, which is specifically on particle count analysis of transformers. And what are the limits which are followed by various transformer manufacturers? A beautiful document. I will recollect it and maybe I will share it with you.
There is a IC also on whole particle count and the class of this
But
whole IC is there.
the most important thing, what I have experienced over last 15, 16 years in instrument transformers and bushings, that particle count analysis technique needs to be perfect. Because you know, it is optical way of identifying particles. If there is any error, then it can give you wrong figures and you
Sir,
can be misled.
to just update, now particle count is happening on site and real condition. There is nothing like you are taking sample and going to lab. So everything is happening online, on site. So
I appreciate.
Yeah,
but
that
you
is
know,
what.
But you know, the technique is if you take a sample online also, but you know, the technique of measuring particles, fine particles, is basically optics related. And that measurement needs to be perfect. And another aspect is that cigarette technical brochure, what I said, is a Bible one. It is somewhere, I think, around 2006 or 2010, that document came up. And now the cigarette technical brochures on power transformers, they give some guidelines on particle counts also. You may refer those. These are good ones.
Hello.
Correct. That I do not know, frankly.
Particle count we are doing 400 kV also, 765 also, and if required 220 also. It depends on the problem what you are facing. Accordingly, particle count on site is done. Shall I stop here?
Yes, ma'am.
Yeah.
Thank you. There is one last question. We had promised him. Oh, sorry. We will hold that applause after this question. Yeah.
Hello, ma'am. Myself, Pranay Joshi from MP Transco.
Yeah.
My question is regarding the core of the transformer. As a utility, we are having a different manufacturers of transformer with us. In some particular manufacturer, we are facing a problem of increasing the excitation current or magnetizing current of our transformer. Somehow they are getting double of the in comparison to the pre-commissioning. So as you told, some pre-inspection tests should be there. If we can stand in that particular test, we can increase the life of transformer. So how can we justify the material of core that will be used by the manufacturer in the transformer during the transformer work, so that the variation in magnetizing current or excitation current should not be happen? Because nowadays when we charge the transformer, the excitation current is too prolonged, so that the transformer trips on the overcurrent during the charging. And because harmonics are there, we can understand this is not an actual fault. But how can we justify that the core material used by the manufacturer is of that up to that quality? How can we justify this?
Sir, the first thing that you are getting the double the excitation current what you face with the commissioning. Maybe that your core is magnetized. So if you want to benchmark, at least demagnetize once or be with that 2 times and let's see what is happening. Making 2 times is okay. You are talking about the quality of core, but as per se the fault, there is no fault in the transformer,
but
right?
As a guideline, the magnetizing current should not be more than 25% in comparison to the pre-commissioning testing result.
Yes, but as you are saying, quality of core, it's a different subject which has to be dealt during manufacturing process. Lot of checks are there, so that those checks has to be done. Losses checks, lamination quality, insulation quality, core building, those things has to be checked during stage inspection.
Any specific test, because the losses, the core material, all the certificates are provided by the manufacturer. But is there any practical cross check so that we can justify, no, there is a good core?
So there is a whole process of core building. If you do this stage inspection, get satisfied by that, it is much better. We can't debate that here. But if you need good quality, you have to have an inspection.
I would like to add here, in CPRI, we have a special test equipment to assess the quality of the core material. there we are doing the hysteresis curve measurement
Okay.
and having the proper value, then we are passing that material.
So those things are already done in the factory. Everything is available in the factory. They do
But
it.
if you are suspecting
Okay.
that, we
Sir,
can
I think you can add more on this.
testing can be done in CPR.
Hello, now we will stop here because it is 5:30 and not 5:30, 5:30 is already over. The banquet hall operator has already shut down the air conditioner also, okay? So we have to wind up this session fast. So please cooperate with me. I have to do 3 short formalities. There will be a lucky draw for 5 gifts at the end. Before that, we will do felicitation. And before that, actually, ma'am, thank you for your presentation. I request you to take the seat. Before that, actually, my college professor, every electrical engineer is having a college professor. So my college professor is Dr. Vishram Bapat. Where is Dr. Vishram Bapat? Sir, please come on the dais. So every electrical engineer has a different life. Like apart from electrical engineer, he is an athlete or he is a businessman or he is doing this and that. My professor, Dr. Vishram Bapat, he is PhD holder. He has many PhD holders have studied under him. There are 35 publications to his credit. And last 10 years, he is living spiritual life. He is an agripreneur. So zero budget natural farming he is doing. Every workshop, we start with a bhajan. But last 7 days, he was having some the spiritual session in Goa. So he could not attend the morning session. His flight was delayed. So we will end our program with his 5 minutes bhajan. I request you to allow me to do that bhajan. Thank you. Sir.
Hello, good afternoon. All the honorable dignitaries on the dais. And it is the nobility of the leader of the organizing team, Jagdish, that he makes it a point whenever he organizes such an event, he tells me that, sir, you have to come for a small time. Now, since I am aging out from the field of electrical engineering gradually, I am 67 running now, but there is no symptomatic indication of near future failure by means of any test as such. Rather, there is no test required at the moment. अब मैं जो आपको सुनाने जा रहा हूँ छोटा सा 5 मिनट का, and I think the song I am going to sing before you exactly fits to the theme of this event, and which is very aptly named by Jagdish as Gyan Sabha. And this is the foundation of the Gyan that is given by Jagdish himself some 5,000 years before to Arjuna. Only some few lines of that song, which is really an abstract Gyan, which fits to every field of life as such in the universe. So, it is the event in the Kurukshetra where Arjuna is confused what to do and what not to. इसमें इनकी बात चल रही है, संवाद चल रहा है. Arjuna is raising question after question, doubts after doubts, that why should I fight this battle? All I see around is my relatives only. So in that, let me not start from the beginning. I come almost to the end where Vishwarup Darshan is given, and where is the Gyan is really in its purest form. So wherein in this course of discussion, Arjun keeps on debating Krishna's points. Finally, Krishna says, ultimate or pre-ultimate order. You can discover what is the ultimate order during my singing. Krishna says, कुछ न बोलो मुख से तुम बस धनुष उठाओ पार्थ, कुछ न बोलो मुख से तुम बस धनुष उठाओ पार्थ, जीतो पहले धर्म युद्ध को, त्यागो अपना स्वार्थ, हे अर्जुन त्यागो अपना स्वार्थ. Next doubt. Arjun still is in the doubting mode. इच्छा मृत्यु धारण किए खड़े है सम्मुख तात, इच्छा मृत्यु धारण किए खड़े है सम्मुख तात, इनके सम्मुख कैसे केशव, विजय हो मेरे हाथ, है केशव विजय हो मेरे हाथ. कृष्णा सजेस्ट ए ट्रिक. अर्जुन क्षण भर के लिए देखना उनकी ओर, अर्जुन क्षण भर के लिए देखना उनकी ओर, छोड़ दे तू भीष्म को और बाण चला कहीं और, हे अर्जुन बाण चला कहीं और. Still he continues in the doubting mode. है पितामह उस तरफ तो द्रोण है दूजी ओर, है पितामह उस तरफ तो द्रोण है दूजी ओर, बीच में कुल गुरु खड़े हैं, देखूं मैं किस ओर, है केशव देखूं मैं किस ओर. That's the end of doubting now, doubting phase. Then Krishna comes to his own spirit now. अब अर्जुन ना देख देख मेरी ओर, ना देख कहीं, हे अर्जुन देखे ना कोई और. Now he is stating the reality of the whole life, universal life, and that is the basic message for us. जल में मैं हूँ थल में मैं मानव के स्वरूप, जल में मैं हूँ थल में मैं मानव के स्वरूप, मैं जगत आधार हूँ, अब देख मेरा ये रूप, है अर्जुन देख मेरा ये रूप. मैं निर्माण करूं इस जग का, मैं पतन आधार, मैं निर्माण करूं इस जग का, मैं पतन आधार, मेरे ही अधीन है ये सकल संसार, है अर्जुन ये सकल संसार. मैं ही करता मैं ही कारक, मैं यौवन में रूप, मैं ही करता मैं ही कारक, मैं यौवन में रूप, मैंने इस संसार में बदले हैं कई रूप, है अर्जुन बदले हैं कई रूप. मैं तपन हूँ सूर्य की, मैं पवन का जोर, मैं तपन हूँ सूर्य की, मैं पवन का जोर, मैं ही नरसिंह राम हूँ, मैं ही माखन चोर, है अर्जुन मैं ही माखन चोर. मैं हरि मैं श्याम हूँ, मैं विष्णु अवतार, मैं हरि मैं श्याम हूँ, मैं विष्णु अवतार, मैं ही घट घट में बसा हूँ, बन के जीवन सार है अर्जुन, बन के जीवन सार। मैं कभी जन्मा नहीं, मैं अमर हूँ पार्थ, मैं कभी जन्मा नहीं, मैं अमर हूँ पार्थ, मैं ही सबसे पहले हूँ और मैं हूँ सबके बाद है अर्जुन, मैं हूँ सबके बाद। मैं जीवन का अंश हूँ, मैं हूँ मृत्यु आधार, मैं जीवन का अंश हूँ, मैं हूँ मृत्यु आधार। जन्मदाता पुण्य का मैं ही पाप संहार है अर्जुन, मैं ही पाप संहार। मैं ही सबसे सूक्ष्म हूँ और मैं हूँ सबसे विशाल, मैं ही सबसे सूक्ष्म हूँ और मैं हूँ सबसे विशाल। मैं ही जगत का पालक हूँ और मैं हूँ सबका काल है अर्जुन, मैं हूँ सबका काल। मैं शीतल मैं ताप हूँ, मैं भादों की फुहार, मैं ही पतझड़ मैं ही सावन, मैं बसंत बहार है अर्जुन, मैं बसंत बहार। मैं ऋतु और युग भी मैं और मैं हूँ सुबह हो शाम। नवग्रह मेरे ही बल है, मैं तीरथ मैं धाम है अर्जुन, मैं तीरथ मैं धाम। मैं अर्जुन संपन्न हूँ, मैं सकल संताप, मैं रहूं जिनके भी सम्मुख, वहाँ रहे ना पाप है अर्जुन, वहाँ रहे ना पाप। व्यर्थ चिंता क्यों करे, क्यों डरे बिन बात, व्यर्थ चिंता क्यों करे, क्यों डरे बिन बात। आत्मा तो है अमर फिर क्यों करे पश्चाताप है अर्जुन, क्यों करे पश्चाताप। परिवर्तन संसार का है नियम सुन पार्थ, खाली हाथ तुम आए धरा में, जाना खाली हाथ है अर्जुन, जाना खाली हाथ। तू है अर्जुन कुछ नहीं, ना तेरे है कोई साथ, सब अकेले है धरा में, धर्म है केवल साथ है अर्जुन, धर्म है केवल साथ। हे अर्जुन अब युद्ध करो, त्यागो मन के विचार। हे अर्जुन अब युद्ध करो, त्यागो मन के विचार। देता हूँ आदेश तुम्हें मैं, विष्णु का अवतार है अर्जुन, विष्णु का अवतार। देख नारायण को सम्मुख, अर्जुन झुकाए शीश। देख नारायण को सम्मुख, अर्जुन झुकाए शीश। रूप था विकराल ऐसा, कई थे जिसके शीश है मानव, कई थे जिसके शीश। जग की हर एक वस्तु को धारण किए थे नाथ, जग की हर एक वस्तु को धारण किए थे नाथ। देख मुख ज्वालामुखी थर थर कापे पार्थ है मानव, थर थर कापे पार्थ। क्षमा करो भगवान मुझे ये रूप न देखा जाए, क्षमा करो भगवान मुझे ये रूप न देखा जाए। इतना कहकर वीर अर्जुन लिया धनुष को उठाए है मानव, लिया धनुष को उठाए। फिर धनुष गांडीव की ऐसी खींची कमान, फिर धनुष गांडीव की ऐसी खींची कमान, जिसकी गर्जन तीन लोक में गूंजी वज्र समान है मानव, गूंजी वज्र समान। भीष्म पिता के चरणों में छोड़ा पहला बाण, भीष्म पिता के चरणों में छोड़ा पहला बाण। समझ गए कि पौत्र अर्जुन मांगे आशीर्वाद है मानव, मांगे आशीर्वाद। फल की इच्छा ना करो, कर्म करो इंसान, फल की इच्छा ना करो, कर्म करो इंसान। सत्य वचन गोविंद कहे, यही है गीता ज्ञान है मानव, यही है गीता ज्ञान, यही है गीता ज्ञान, यही है गीता ज्ञान। धन्यवाद।
Sorry, I have taken this risk, but as I promised you, Gyan Sabha, the unknowns have many dimensions, and I wanted that this dimension of spirituality should come into your life. We have read many white papers which have just written recently by engineers hundreds of years ago, but there are white papers which are written thousands of years ago and that have a greater depth, and that dimension balances our regular life also. I am sorry I have added this to this. Now with this, I'll request Mr. Negi to felicitate Dr. Vishram Bapat. Sir. Udhar se. हाँ सामने. I also request a big round of applause for Dr. Aradhana Ray for her wonderful question and answer session. I request dignitaries to come downstairs. Yeah. Now there will be lucky draw and one announcement at the end of the show.
अभी भी कुछ लकी लोग बाकी हैं, क्या आप उसमें हैं? जी,
सर सेवेंटी वाले सब नीचे हैं, चलिए कोशिश करता हूँ कि कुछ ऊपर वाले आ जाएं। जी 717 के बाद, हेलो 717 के बाद में 7 नहीं सर, 7174 कोई है क्या? 7174 नहीं है सर, एक और निकालिएगा प्लीज, वन मोर, यस सर। 7006 70 प्लीज आगे आ जाइए सर, सर प्लीज आगे आ जाइए सर। 7295 7295 एक निकाल दीजिए। 7295 सर, नेक्स्ट नंबर सर, इधर आप निकाले थे ना? 7133 7133 जोशी सर, साहेब तुमच्या थोडे करू ना। 7252 7252 प्लीज सर। 7123 7123 ओके, थैंक यू। या तो सर निकाले दो और, ओके थैंक यू। अभी नहीं माइक।
So tomorrow at see, basically we have to end the session tomorrow early, so we will start tomorrow session sharp at 9:30. I request you to join for tea and coffee and breakfast at 9 o'clock or 8:30. At 9:20 we will have lucky draw of 10 lucky draws between 9:20 to 9:30. Those who are present will only get the lucky prize. Okay, and second, but don't miss the tea and breakfast also, because that will be closed after that. Second important thing is Dr. Rajamani is going to present his wisdom of 10 O&M mantras. His presentation is at 9:30. Please take the make good use of this Gyan Sabha and do not miss his lecture. So we will give award, the lucky draw prizes. 7163, one more lucky person. 7163. So please come. Yeah. So I will request Mr. Jitendra Mamtora to felicitate them with this lucky draw prize. Sir, your good name and introduction.
My name is Haryo Mishra. I am from TrueBoard Consulting team.
My name is Tirupati. I'm from Region Infrastructure Private Limited from Chennai.
From Chennai, great.
My name is Chaitanya Dupare. I am from MSP GCL.
Mahajanko. Thank you. Thank you. So with this, I announce it is end of the day 1. Let's meet tomorrow for tea and coffee at 9 o'clock sharp. Thank you.